Good morning and welcome to our session 4 of our Geoscience speaker series. I'd like to acknowledge that I live and work within the traditional territories of the Kwanlin First Nation and the Tonquichan Council. My name is Brianne Warner. I'm the Executive Director for the Yukon Chamber of Mines. And this is my co-host, who you may hear in the background occasionally, 7-week-old son Nash. Now, the difficult decision to cancel this past year's Geoscience had us pivot to offering our Geo Talks through this month's speaker series. I'd like to thank our generous sponsors who have allowed us to offer these talks free of charge to our registrants. It is extremely important to the Chamber to ensure we continue to offer opportunities for industry to network and communicate their achievements and attract investments to our territory, whether it be in person or over Zoom. In the coming months, we look at continuing to offer this type of series. Please take the time to go check out our online silent auction put on by the Yukon Northern Safety Network, along with Yukon Chamber of Mines and Yukon Reed Society, to raise money for the Yukon Imagination Library and the Yukon Mines Legacy Foundation. The auction will end on Thursday, January 27th at 12 p.m. Yukon time, and the link will be posted in the chat. If you have any technical issues, please contact events@csrmanagement.ca. At the end of our session, we will offer a Q&A with our speakers. Please type your questions into the chat and our moderator will ensure they are answered. These sessions will be recorded and posted online at yukongeoscience.ca. Special thanks to our partners, BMC Minerals and Yukon Government, as well as our gold sponsors, Air North, Yukon's airline, Alcan Air, Archer Cathro, Cobalt Construction, Hummingbird Mobile Health, Newmont, JDS, NVD, Pelly Construction, Summit Camps, and Invest Yukon. With that, I will hand the mic to Maurice Colpron to introduce our first speaker.
Thank you, Brianne. So we have a busy session today focused on the Dawson Range and porphyry copper deposits or related deposits in the Dawson Range. So I won't speak too long, and we'll just get the session going so we can finish on good time. Our first speaker this morning is Warwick Bullen, who's a mineral assessment geologist with the Yukon Geological Survey. And Warwick will talk to us about his work on predictive indicators for porphyry-style mineralization. Up to you, Warwick.
Okay, thank you, Mo. So, as Mo said, I'm going to look at predictive indicators for porphyry-style mineralization using deconstructed weights of evidence modeling, which is it's not entirely it's not at all a new mineral potential mapping technique. What is new is the deconstructed part of this whole process. And the reason why I'm doing this is to hopefully provide industry with some decision-making tools, particularly in terms of strategy, things like risk, exploration risk, and also just as a straight-out prospectivity tool. So this weights of evidence approach is, as I said, it's not new. It was started off in the health industry as a way to try to predict if somebody had certain symptoms, whether they would develop a particular disease. And that was in the early 80s. That was then, with the advent of GIS, that was then adopted in a sort of spatial sense. This whole weights of evidence stuff by some very smart people within Arcan predominantly, also with USGS and other people, but it was to a very large extent driven by a Canadian contingent of people. And what it does is it uses Bayesian statistics. So it uses Bayes' formula, which is all about conditional probability, to calculate spatial associations between training sets, in this case, mineral occurrences, and predictor maps. And so it's very useful. Bayesian statistics is very useful if you're dealing with incomplete data sets, which is what exploration is all about. You do not know you do not fully understand your ore body literally until the last ton of ore comes out of the ground. So you are, as an exploration geologist, you are always making decisions with incomplete data. So conditional probability allows you to make better decisions, if you like. So the way it all works is you calculate the strength of the spatial association between mineral occurrences and your predictor maps, as I said, and then you assign weights to whatever these predictor maps might be, and I'll define them in the next slide. And then you sum them together, and so you end up at the end of the day with a prospectivity map. What I don't do is sum them together, and the reason why I don't do that is because when you sum them together, you can quite easily get lost in the detail, and you lose track of what it is that's informing these predictive areas and so on. The graphic on the right there is just it describes in how the weights of evidence and process works, and you can look at that at your leisure when afterwards. Okay, so there's some basic ingredients in the whole process. So what you first of all need is you need some mineral occurrences to work with. So you do have to have known mineral occurrences. In this case, we're dealing with porphyry deposits and porphyry occurrences in our MinFile database at the Geological Survey. You then need to take your area, whatever area you're looking at, and divide it into a grid, which are called unit cells. And then you need to have data that you feed in. So you could have faults, you can have geochemical data, rock types, whatever geological data you feel is relevant to the prospectivity assessment that you're currently doing. And these are called evidential themes or categorical features. I'll call them categorical features, but they equally can be called evidential themes. And then also you have weights. And so what weights are done is, this is where the whole Bayesian statistics comes in, is these weights are calculated to provide a measure of the categorical feature, let's say it's a fault in this particular case, as a predictor of mineralization. How strongly does the fault then predict mineralization or not? And you have W plus and W minus by convention, and W plus is the weight of the categorical feature itself inside, and W minus is the weight of the area not covered by the categorical feature. So you have to look at both of these at this pair at the same time. And if you have a positive weight, what it's telling you is that more points, more mineral occurrences occur in association with the fault in this particular case than simply due to chance. And if you end up with a negative weight, it's telling you that the opposite is the case. And then what happens next is that the weights are summed, W plus and W minus, and you get something called a contrast. And the contrast then simply measures the strength of the spatial association between the categorical feature and mineralization. And then the last two important sort of basic ingredients is the notion of prior probability, which is the probability of a mineral occurrence occurring within a cell before you've taken any categorical features into account. And the posterior probability is the probability of a mineral occurrence occurring in a cell after you've taken the categorical features into account. So when you look at the graphic on the left here, this is from Eritrea, just outside Asmara, either earlier on last year or the year before. And this is exactly what these guys are doing. So they're taking a whole lot of, they've got mineral occurrences, they've divided the area that they're looking at into unit cells, and then they've taken a whole lot of categorical features, in this case, remote sensing maps looking at alteration and gossans, geochemical data, mapping data, faults, and so on. And these are all the layers that they're bringing into this weights of evidence process that they are using to generate a prospectivity map. In this case, it's for gold, associated with VMS deposits just outside Asmara. So the mathematical process, I mentioned earlier that when it was developed by NRCan primarily, plus others, the mathematics is quite involved, and these, you know, the people who developed this process did a very excellent job. And so what I've done here is I've sort of simplified how it works. I'm not going to go into any detail here, but basically there's 3 steps, and the 3 steps are as follows. Number 1 is you need to calculate the prior probability of a mineral occurrence occurring in a cell, in a grid cell. Step number 2 is then to take Bayes' theorem and to calculate the conditional probability given whatever categorical features you're looking at, faults, geology, geochemistry, whatever it is. But in order to simplify the whole process, what happens is that natural logs are taken of the probability. And when you take a natural log of a probability, what you do is you convert it to odds. So the process runs instead of looking at odds in terms of probability. And the reason why you take the natural logs is because you can then take the Bayes theorem and you can simplify it. You can remove or switch the multiplication signs to plus signs. And then it becomes much easier because then you can simply just add the weights together rather than multiplying weights and so on and so forth. So it's for simplification processes that the logs are taken, and they're actually called logits. I'm not sure if I ever learned about logits at school, but it was definitely something I had to look at. When you take the natural log of the probability, you end up with something called a logit. And then in step number 3, right at the end of the whole process, is you simply invert everything and you convert from natural logarithms back to probability, and then you can start finessing your prospectivity map. So that is it in a very simple form. And I think, I've got all the details if anybody's interested, but this is certainly beyond the scope right now to go into too much detail. So what is very important is understanding the notion of prior probability and posterior probability. So if, let's say, for example, you have an area with 100 cells, that's the one at the top, 10 by 10, 100 cells, and you've got 10 mineral deposits randomly located somewhere. Your prior probability is quite easy. It's 0.1. In other words, if you randomly locate yourself in that grid of yours, there's a 1 in 10 chance you'll land on a mineral occurrence. However, once you start looking at categorical features, you then need to take the weights into account. So if, for example, you just have the categorical feature that's represented by the dark orange, in which there are 6 mineral occurrences represented by the X's, the probability that if you randomly land anywhere in that dark orange rectangle, that you will land on a mineral occurrence is 0.25. If you take the yellow and you apply the same logic, it's 0.15. You've got 3 mineral occurrences and 20 cells. But when you have both, then you need to apply a function which involves the weights of both of the categorical features, both the weights inside the categorical feature, the weight outside the categorical feature. And so they are not simply additive. And it's not a complicated function, but it just needs to be borne in mind that let's say, for example, you randomly land on the square with a black circle in, the sort of light orange. It's not additive between the dark orange. The prospectivity is not additive between the dark orange and the light yellow. It is a function of the weights, both inside and outside of these categorical features. And when people build these prospectivity maps using weights of evidence, this is how it's done with all these various calculations. So let's have a look at some of these maps very quickly. These are 2 maps built using weights of evidence. One is from India, from the Aravalli Delhi Fault Belt, which is a aesthetics territory, aesthetics province rather, and then British Columbia, which is more familiar to people looking at porphyry style mineral deposits. So what you see, first of all, is that by coincidence, these 2 maps have the same shape, and that's purely by coincidence, but they actually look the same. They've got the same look and feel about them. And that is not by coincidence. That is a function of the fact that NRCan, back in the day, developed an ARC view plugin for ArcGIS that would assist with the making of these weights of evidence maps. So the outcomes in many instances look the same, and you can see even the legend looks quite a lot the same. So, and we're going back in time, by the way, with this Arc plugin back to the mid-90s, and this NRCan doesn't put out this plugin anymore, but you can still get it off GitHub. In fact, you can get it for ArcGIS Pro. So there are some dedicated people that are keeping the software going. And if, let's say, for example, if you look at the map on the right-hand side, and you would produce a mineral potential map like this, it's very, very useful, obviously. And you would say, well, I think we should, ideally stake all ground that is yellow, orange, red, and immediately start drilling out all areas that are red. And the problem with that is it's correct, but what you don't see in a map like this immediately is what's actually informing these high prospectivity areas. What's going into them that's making them high prospectivity, and one red area may not necessarily be the same as another red area. And to be sure, these maps come out with detailed explanations, but these detailed explanations are in many cases not easily accessible to the person who may be a decision maker in the company. And so I thought to myself, I've often looked at these maps and thought, perhaps there's another way to present the same data, but in a way that's slightly more accessible. So what I did, and some people in the audience may have come to a talk I gave when I was first trying to wrap my mind around this last year in March or April, how one could do it. And the map, what you're seeing now, looks completely different. Obviously, you can't see the detail, but this is the map that I've come up with, which sort of breaks down what you're looking at in the previous maps, but in this case, it's for Yukon. And at this point in my talk, I was going to tell people in the audience, okay, you can just head off outside now because this is for Geoscience Forum and the map will be posted up outside. That's not the case now, obviously, but the map has been done and it will be released literally, I think, within the next few weeks. So just to step through, there's a whole number of components on the map, and I've just marked them all, and the map in itself is self-explanatory. So you don't need to have a separate 50 or 60 page explanation which can become really, really technical. Ideally, what I'm trying to do here is to put this map out so that whoever looks at it can immediately understand what it is that they're looking at, and what it's, more importantly, what it's actually telling them. So there's a section on definitions, there's a section on the mathematical treatment, there's weighting factors, there's different categorical features, terrains, bedrock geology, gravity, air, and mag. There's a whole bunch of these things. And then there are the tables in each map which describe clearly what it is that these various attributes are telling everybody. And over on the right-hand side, the rock types are broken down so people can see what rock types are which, because you can't see them in the map on the top left-hand side. And also there's a hierarchical table, of sort of exploration hierarchical table that I made up to account for prospectivity and area, because you may have something that's very prospective, but the area might be quite small. So that needs to be, if you're sort of strategizing about what you want to do when you come to Yukon to look for porphyries, you would need to take that into account. So I'm just going to very, very quickly have a look at some of the various aspects of the map so that people can understand what it is. So if we look at terrains, for example, and we run the weights of evidence, but without getting to the end where we add everything together, we find that the Stickinia and Rangelia terrains are strongly predictive for porphyry mineralization. The Yukon Tanana terrain is less so, but it's significantly predictive. So what does that mean? It's telling you that basically if you were sitting in your office and strategizing, what you would probably want to do is you would want to say, okay, first of all, which is a bit of a no-brainer, we need to focus on terrains which have a positive contrast value. In other words, which are statistically positive for porphyry mineralization. Then if you were sitting in your office and you said, okay, fine, I think we should focus on the Rangelia terrain, for example, because it's the most strongly predictive, then you can go along and you can have a look at the probability of a deposit occurrence in the Rangelia terrain, which is 11.2. And what that means in practice is that if you were to randomly locate yourself in terrains in Yukon, which have a positive contrast value, which in other words are statistically positively mineralized from a statistical point of view, and you landed in the Rangelia terrain, you would have an 11 times greater chance of landing on a mineral occurrence than you would if you just located yourself randomly in positive contrast terrains. And so you might say, well, that's what we've got to do for sure. It makes a lot of sense. It's a reasonably large area, as you can see on the right-hand side. Area is quite important. Should we go there? Yes, no, maybe. Well, then you would look at who was there, for example. So you would say, well, Strategic Metals has sewn up some pretty good ground there. So do we stake some ground? Do we talk to them? And so on. Or you could say, for example, well, let's increase our chances, focus on the Yukon Tanana terrain, which is much bigger, significantly prospective, and we have a better opportunity. So these are the kind of decisions that this way of looking at data can help people with. If you look at the geology, for example, there are some very strongly predictive rock types there. And if you look at the probability of occurrence, you'll notice that there you can increase your probability of randomly landing on a mineral occurrence by over 15,700 times. If you take the focus on the very strongly predictive rock types. And the question you would need to ask yourself is, well, who are these people who own this very strongly predictive ground? Who would they have to be? And in that case, they would have to be Granite Creek, because Granite Creek own or have property which covers very prospective rock types, or the pavose, these migmatized rafts, which are limited in space and XY in the XY extent, but obviously not so in the XZ extent. And then you would perhaps have a discussion around, well, if they're so hard to find, maybe we should look for something else, or because they're very hard to find, maybe we could find more. And so that's the kind of logic process that you can go through. And I'm just touching on a couple of things here. There's obviously a whole range of discussions you could then have sitting around a table in your office, or whatever the case might be, before you came out, before you arrived, at what sort of strategy you would use. There's line and point data, which is really important. And so think of faults and fault intersections for line and point data. And when you are looking at this data, when you look at the literature, what you see is people look at, well, how far should we buffer these things? These things are always buffered, by the way, because faults and all point data, the influence extends beyond the actual structure itself. What you would do is you would determine what is your optimal fault buffer. But what people don't seem to do as much, and I haven't seen it much in the literature, is you need to look at trends. So when you start looking at trends and you start moving away, if you look at the top graph on the left-hand side, which looks at non-intrusive contacts, and you look at the x-axis, if you stand on the 0, you're standing on the structure, in this case, for the contact, the linear data, and you're moving away 200, 400 meters, and you need to look at trends, because if you, from the point of view of contacts, if you took a buffer of, let's say, 800 or 1,000 meters away from the contact, you would end up with something that was had a reasonably high contrast. And you would say, oh, look, non-intrusive contacts are important for porphyry mineralization, where in fact, if you look at the trend, it looks like a variogram. They are not, because as you get closer, so the contrast drops off. So that's just an important point I want to make regarding line and point data. And you look at the other graphs, and it's clear some of them are quite, contacts, for example, and contact fault intersections are quite prospective for porphyry. There's gravity and error mag data. There's also stream sediment data. I've just got a couple of minutes, so I'm going to rush through this quite quickly. Bill Mann, when I gave the talk last year, he said that he pointed out that porphyries tend to be associated not with lows or highs in Yukon, but with somewhere in between. And so I said, that's very interesting. Thanks very much. Let me look at that. And I've done that. And he's absolutely right. That's exactly what happens. And so what I've done is I've taken gravity and error mag data, divided both of these categorical features into 13 class intervals, and then run a weights of evidence on it and to see where they come. And gravity intervals 4, 6, and 7 are weakly significantly and moderately predictive respectively, whereas aeromag intervals 11 and 12 towards the higher end are significantly moderately predictive, as you would expect. So Bill Mann was absolutely right on the money. I've also done the same thing for stream sediment data, and I've done it slightly differently, and I've introduced a new method for calculating anomalous data using ARC. I've written it up in a YIG paper, and that'll be coming out, I think, in the next couple of weeks, so people can check that out. And we found that, and I've actually combined the basins into one anomalous basin, or it's a 2 anomalous basin, 3, 4, and 5, and so on. There are no 6 anomalous basins. I've just used primary elements here. There are no 5 anomalous basins, which is a good thing, I'd have to say, but there are 3 and 4 element anomalous basins are significantly moderately prospective, and 1 and 2 are weakly to moderately prospective. And then the map also contains additional information to help people identify rock types, a kind of an exploration hierarchy indicator, which looks at both the probability of a mineral occurrence and the area that you have to play around. So I've just got a few more slides, which I'm going to whip over. I've just checked to see that it all works out, what it looks like. I've looked at Casino and where Casino sits in terms of all these predictive indicators, because ideally it should stand out like a sore thumb, and it indeed does. So it's associated with highly very strongly predictive rocks. It's faults. It's there's important gravity data, mag, and also geochem. And I've done the same with revenue and nucleus, and the same applies. I'm not going to go through it for time reasons, but you can certainly go through it at your leisure. And then finally, just a couple of take homes. I think, first of all, I like this approach, and I think it helps. It's going to, potentially can help people, as I said, from a range of things: make decisions, reduce risk, basic prospectivity, and it's a new way of presenting. It's a back to basics approach, if you like. It's a wholly data-driven process, which has advantages and disadvantages. Let's be clear. It breaks down the maps into constituent parts, which is good, and it's completely scalable. So you can take this kind of process and do it on your property using proprietary data to help focus in and make good decisions. And it forces the user to really look at the data that they have. You can take, and it quantifies everything. So you can take your quantified data and actually add value to your quantified data. Helps in exploration, decision-making strategy, and also aids in risk reduction. So that's all I want to say. There's obviously a lot it's a very big subject, and there's a lot to be said about it, but I certainly thank you for your attention. Okay, thank you, Mo.
Thank you, Warwick. Thanks for the presentation. And Warwick made a few mention of things that are upcoming. So yes, we're busy at YGS getting our publication, our annual publication, the YEG volume should be ready by the end of next week, so that you'll be able to find it on our website for Roundup. Unfortunately, we won't physically be at Roundup, any of us, for a reason that we all know, but we will have a virtual booth, so I invite you to go and visit that. So the next talk is by Patrick Sack, who actually is going to take us underground and show us what some of the rocks that Warwick's studies are predicting. So go ahead, Patrick.
All right, hopefully everybody can hear me. So my name is Patrick Sack. I'm going to be presenting today on the geology of the Mount Nansen district. That's just outside Carmacks. I'll spend the first half of the talk there, and then I'm going to zoom out a little bit and kind of step all the way across the Yukon from the BC border to the Alaska border. And I'm also presenting a lot of data from Welshen Lee in here, so mostly from his PhD study that he recently finished at the Claza deposit. This is just a cover slide of the Brown McDade pit down in the bottom left. So one of the classic deposits from the Mount Nansen district. So just to put that a little bit into a spatial context, I'm going to start the talk by talking about the bit of the detailed geology in the Nansen map area, which is this red dot in the middle of the map there. And then I'll finish off the second half of the talk. We'll kind of step out to Dawson Range. That's a pretty loose use of the word Dawson Range. It's outside the Dawson Range, but that's basically where we'll go today. So the intermontane terrains broadly between the Denali and Tintina faults. This is just a screen grab of the new updated Nansen geology map sheet. This is sitting with the editors right now, so it should be out, I don't know, in the next month or two, I would imagine. And in a real simplified look at the geology in the Nansen area, you can split the geology into a metamorphic basement, shown here in gray, predominantly found towards the southern portions of the map sheet. Shown here in green are mid-Cretaceous rocks. So these are both volcanic and plutonic rocks in the center and the northwestern part of the map sheet. And then these are all covered and intruded by late Cretaceous volcanic and plutonic rocks. The big slug of red up in the northeast is Carmack's basalt, and most of these little pimples and plugs and dikes throughout are Prospector Mountain or Casino Suite intrusions. Just to get some terminology straight, because I find the Nansen district a little bit confusing, I kind of break the mineral occurrences into two clusters. Down on the south, near the contact between the mid-Cretaceous batholith rocks and the basement, we have the Brown McDade cluster. So this would include the Brown McDade deposit, the Flex deposit, the Weber, the Eustis. It would be a little bit of what you might be called the classic Mount Nansen district. This would be where the past production has happened and where most of the development in the district has happened. This cluster more in the center portion of the map is probably familiar to anyone that's been at Forum in the last 10 years. The Claza deposit is up there. It also hosts what's called the Kelly Cypress occurrence, the Kelly occurrence and the Cypress occurrence. And that's, we're going to go into a bit of detail on that because we've got some new data that helps sort of explain what's going on in there. I just find this confusing because the Claza Kelly Cypress district is actually closer to the Mount Nansen proper than the Brown McDade. So I've sort of tried to get rid of that terminology, at least for this talk. So just a few rock shots to walk through the geology. The oldest rocks in the area are the snowcap assemblage. These are metasedimentary rocks of the Yukon-Tanana terrain. And the Finlayson assemblage and the Simpson Range Suite. This is a metamorphosed volcanic plutonic complex. These are mostly mafic volcanics. The Finlayson Range or Finlayson assemblage, is mostly mafic volcanics with a bit of metasediments, shales or carbonaceous phyllites now in there. And these are metamorphosed granodiorite type intrusions. All of these are intruded by the Minto suite. So these would be the late Jurassic plutons that Mo and I just published on, and there's tons of information if people want. Can help you out with that. When we get into the mid-Cretaceous, something's gone. Yeah, so that's basically the metamorphic basement to the district, the geology in the southern portion. The mid-Cretaceous rocks, it's a volcanic plutonic complex. The volcanics are dominantly andesite. So this is just a shot here of the massive andesite with plage phenos. There's all sorts of textures in these rocks. There's autoclastic breccias, rounded breccias. There's a little bit of felsic material, but the dominant story for the Mount Nansen volcanics is that they're andesite or andesitic. And then the other very common rock is this Whitehorse Sweet hornblende or biotite hornblende granite diorite. This would be sort of the Dawson Range batholith and part of the Whitehorse Sweet mid-Cretaceous. If you listened to my talk last year, I tried to probably convince some people that rocks like this is a sparse quartz feldspar porphyry. Looks very much like some of the rock you find around Plaza and some of the rock that's been dated elsewhere as being late Cretaceous in age. I probably tried to convince you that this was a late Cretaceous rock. I'll walk you through why I don't, well, it's not anymore. This is a shot of the Dixon knob. So we're down now in the Brown McDade cluster of deposits. This knob here and both of these little pimples on the side are that quartz feldspar porphyritic rock. This is just a view looking sort of northeast over Cabin Creek. The Flex deposit is there in that pre-stripped area. And when you look in core from the Flex deposit, this is what you see. You see this is one of these dikes, so feldspar quartz porphyritic texture and all cut by mineralization and altered. In this case, it's mostly pyrite in there. So not necessarily economic mineralization, but mineralized for sure. My YEG that's just in the, in the editor shop right now has the data on a sample from one of these little plugs, these quartz feldspar plugs. And in fact, it's not late Cretaceous, it's solidly mid-Cretaceous, which is the same as what Mort and others had documented through here, but they had done all of their dating on drill core and the actual surface expressions hadn't been dated. I thought I was onto something, but I was not. And potentially more interesting is this rhenium osmium moly age that's going to be coming out in a paper of Welsh-En's that's due to be submitted to economic geology quite soon. And it's got it's the first rhenium osmium moly age for the Brown McDade cluster, and it is solidly mid-Cretaceous and really makes good sense with the known zircon geochronology in that the dikes and the mid-Cretaceous magmatism is coeval with mineralization. So for my interpretation, this Brown McDade cluster, so the Brown McDade pit and others, I would say all the mineralization down here really is mid-Cretaceous and not related to the stuff at Plaza Porphyry and others, as we'll get into next. The late Cretaceous rocks. The oldest late Cretaceous rock on the Nansen sheet is this 78-year-old, 78 million year old microdiorite. This is a sample from the Kelly Porphyry, and that 78 million years probably puts it in the Casino Suite age regionally. Immediately underlying the Carmax basalts is a 72 million year old alkali felsic tuff or alkali rhyolite tuff. And the Prospector Mountain Suite, this is a shot of rocks from the Cypress Porphyry. These are 71 million years. And then the end of that late Cretaceous magmatism is the Carmax basalt. This is just a shot showing the alkalic nature of those rocks with, in this case, pyroxene phenocrysts. So we'll zoom in now to that Plaza Kelly Cypress cluster. This is based mostly on what Welsh-En was able to document in the Plaza deposit. So really the short story here, if you read Welsh-En's thesis, is that there's casino mineralization, so late 70s MA mineralization, porphyry mineralization, and it's overprinted by Prospector Mountain porphyry and epithermal mineralization. So if we just look at a cross section through there, right in the middle of that slide is Nansen Creek. All these creeks with yellow highlights are placer producers. So placer gold is pretty evident in this district. And talking to Jeff and those guys, there's probably something like 50,000 ounces of placer gold has been produced out of the Nansen, out of these late Cretaceous fed streams in the history of placer mining there. So you can just see the Kelly Porphyry sitting down here immediately south of Claza is this red Casino age body, and the Cypress Porphyry is this blue body over here, just on the other side of Nansen Creek, with the Claza deposit shown up here. And we show the dike swarm. If you can see, it's pretty faint, but the dike swarm is red, which suggests that we think it's all Casino age. We know, in fact, that it's not. There are Prospector Mountain age dikes in this district, or in this property, but telling them apart without an age date is quite challenging, and so they've remained sort of one color on the map. And Welshan puts this together and sort of describes this as a model where the Kelly Porphyry is emplaced relatively deep and quite hot. There's Molly ages of sort of 76 to 81. The porphyry mineralization has quite a bit of potassic alteration and sort of these squirmy, deeper porphyry veins. And then, so that's sort of, let's say, like 78 million years ago. And then around 71 million years ago, there's multiple 71 MA Molly ages for the Cypress Porphyry. And we've got a 71 MA zircon age that Welshan's putting it out in his SEG paper that's to be submitted soon. And then there's lower temperature controls on mineralization over in the Claza, cross-cutting relationships between veins and dikes, and then some low temperature UPB, calcite, and argon-argon ages suggest that this is a distal expression, so probably an epithermal expression of the Prospector Mountain porphyry. Same thing, Welshan puts together such nice diagrams. You have to show them when you get the chance. This is a view looking, kind of a long section, if you will, looking across, or sorry, sort of along the Claza veins and then down into the Kelly Porphyry with the Cypress Porphyry down on the end. You can see the different epithermal veins in here in the Claza, getting into some of the higher temperature squirmy veins in the Kelly. So these would be Casino age, and then back to the Prospector Mountain age, so the 71 MA with some of these like probably higher level porphyry emplacements is tourmaline cemented breccia. This metal zoning also points back towards the Cypress Porphyry as a heat source for some of that Claza mineralization. And just some more rock types. Lots of good porphyry documentation in here, magma mingling in this top row, to emphasize some of those squirmy veins, deeper veins from the Kelly Porphyry. And then finishing off with some of the Cypress, sort of volatile rich cemented breccias with the tourmaline breccia here. So that's all work that Welshan has done and documented and is, I'm pretty sure, available in his thesis now. So if we step out a little bit and look at, that's where we kind of shift gears now for this talk. We look at the Yukon in writ large for mineralization, and the big impetus for looking at the late Cretaceous rocks is actually pretty easy to see on here. This is just a summary of data from the Yukon. We've got age along the bottom, and then zircon and moly ages, some data extracted from the geology map. But really, it's pretty easy when you look at Scott's deposit compilations and you look at contained copper and gold in the Yukon. Really, you want copper and gold, you want to be in the late Cretaceous rocks. We could all know that the majority of this is in Casino deposit, which Carl will talk about later on, but there's also a lot of other deposits and occurrences of this age, making it quite a prospective time slice of Yukon. So here's just a very stripped down version of the Yukon. All that's shown here on the colored rocks are late Cretaceous magmatic rocks, so plutons and volcanics. And I just want to show that there's a progression in the plutonic suites and the ages of magmatism as we go to the northwest. So we started southern Yukon with the Rancheria Windy Table in the high 70s, low 80s. The majority of the Casino Lansanlin rocks, these are high 70s MA. They're found in kind of the central piece. And as we go out to the Alaska border to the northwest, We get more Prospector Mountain, and to a certain degree Carmax. Carmax is quite widespread, but this would be the youngest phase of this. So in the sort of low, high 60s to low 70s. So a similar map, slightly expanded so that we can cheat into Alaska and BC a little bit. These gray stars are mineral occurrences. And if we look at deposits and occurrences with a decent constraint on the age of mineralization, we see a similar northwest trend. So we go from Red Mountain, which down in southern Yukon, and Adanac Moly in northern BC. Red Mountain, we have a new Moly age of 82.5 million years. So that fits quite well. The Rancheria Suite ages, if we go up to the sort of the Casino Suite, so this is the high 70s. We've got some really striking similarities at 75 million years, repeated analyses at repeated deposits at 75 million years was pretty significant for, at least for Moly. And potentially of interest also is this, the fact that if you believe UPB calcite dating from the Rakla belt or Nadaline deposits, this is probably the same age as mineralization out in the Carlin type deposits in Rakla, which is food for thought for later on. And then if you continue up into that low 70s, high 60s age, again, we have repeated deposits with repeated Moly ages that seems to be 71 MA, and maybe a bit younger if you get into the zircon ages. I think Adam's going to tell us a bit about Connaught up here, and I should say Luke is going to tell us a bit about the Hopper, which is down here. So some of these details will flesh out in the other talks today. Chemically, these rocks are also distinguishable. The Rancheria Suite is alkaline with sort of an involved trace element signature. Casino Suite is a bit more calc-alkaline with a bit more variety, but a subduction related signature. And then Prospector Mountain is alkalic again, but this time has a more subduction related trace element signature. If we skip to isotopes, we get a similar story. This magmatic cycle from around 82 to 67 million years evolves pretty systematically from an evolved sort of crustal, or at least highly crustally contaminated source through to a quite juvenile source. We see that in multiple isotopic systems, neodymium here, strontium there, lead there. And this will all be data that we're trying to flesh out and add to. So just to summarize what we see in the magmatism and mineralization for the late Cretaceous, we see a northwest progression. So we have the Rancheria Windy Table magmatic event in southern Yukon at the sort of low 80s to high 70s, predominantly alkalic in chemistry, but quite isotopically evolved or crustally, speaking to a crustal source or contamination. Center part of the belt, we have that Casino Lansanlin magmatic event, slightly younger, high 70s. It's got a more of a typical calc-alkaline trend and is again kind of intermediate in the isotopic composition. And it finishes off towards the Alaska border with the Prospector Mountain / Carmax magmatic event, bit younger again, so low 70s to high 60s, back to that alkalic nature, but now it has an isotopic signature that's quite juvenile. Just a summary slide here. This is my last one. And I don't have any answers now. This is where we'll hopefully get some discussion going at the end. But this is just to point out that the Cretaceous, and I kind of suspect really the late Cretaceous, is a time of pretty considerable change in the Cordillera. So the figure on the right is out of Munger and Gibson's kind of big picture summary diagram, and all those little dots are where things are happening in the Cretaceous. Now it's a bigger time slice for them. They did 120 to 60. But I think there's a lot of things in there that could be helping with porphyry mineralization. So there's changes in the origin normal to origin oblique tectonics, maybe a change in subduction angle. There's increases in sedimentation rates. There's a potentially diachronous closure of the back arc basins that sit between the insular and intermontane terrains down here. You could be subducting strange things or sort of crustal weaknesses. One thing that's quite fun to think about is that this might be the time that the The resurrection plate actually went down the tube, so that might provide a mechanism. And maybe there's changes in subduction rates. So all of these things are possibilities, and I don't know the answer, but that's it for me today.
Thank you, Patrick. Nice presentation. And as you all know, you can put in your question for the end. We'll come back at the end of the session with the Q&A session. And so any question for Patrick or anybody during the session, please log them on to the chat or the Q&A box, and we'll go through that later. So next, keeping on the theme of looking at Porphyry Belt in Southwest Yukon, we'll get Steve Israel to come up and give his presentation on this work.
Okay, thanks, Mo. And Patrick, thanks for your talk and work as well. Some really interesting stuff. Patrick, you did a good intro to part of the stuff I'm going to talk about. And essentially, what I am going to talk about is a really brief sort of summary of the Mesozoic to Cenozoic porphyry belts in Southwest Yukon. And as I said, Patrick sort of touched on the late Cretaceous, and I'll be going through basically from the mid-Jurassic. I'm not going to touch on any of the Triassic or early Jurassic stuff, but mainly stick to middle Jurassic down into the Cenozoic, so basically the Pliocene and Miocene in Southwest Yukon. And what I'll be doing is giving a brief summary of that, of the tectonics of Southwest Yukon, and then I'm going to throw out a bunch of examples of these porphyry systems from a strategic metals point of view and the properties that they currently hold within that Southwest Yukon. These are pictures of some of the properties. The Mint property over here on the screen's left is a Miocene to Pliocene age porphyry system. The Malloy in here is Paleocene, and then the CD property is part of that late Cretaceous suite that Patrick just talked about. Some cautionary statements. Okay, so stepping back a little bit, this is obviously a map that everyone's pretty familiar with, the entire North American Cordillera, or at least the northern North American Cordillera. And you can see that the majority of the porphyry deposits in Yukon and BC are found within the intermontane terrains. And of course, there are exceptions to this rule, and I'll touch on some of those a little bit later on. And as far as ages go, you go basically from the Triassic all the way into the Neogene. And so you've got systems of magmatic rocks producing these kinds of deposits, basically encompassing over 200 to 216, 220 million years of life in the Cordillera. And of course, they're hosted in calc-alkaline and alkaline intrusions all the way through the belt. And I threw this up here not as basically just as a reminder really of where porphyry systems generally occur. And everyone knows this kind of stuff, but it's nice to look at. Generated in magmatic arc settings, compressional to oblique compressional tectonic settings are ideal for these kinds of things, especially in transpersional and transtensional, because you're developing these large scale crustal features that allow the magma to enter up into the upper crust. But it's not full on extension, so it gives the magma time to actually assimilate some of the crustal material that it needs to generate some of these porphyry systems. They're generally associated with I-type, medium to high K calc-alkaline intrusions, typically sort of metaluminous in character. And of course, the shallow level of emplacement is key to developing porphyry systems. And also we need that preservation of the system as well. So minimal amount of exhumation and erosion. Again, I threw this up. Everyone is really familiar with this diagram from Silito in 2010. These are really, really well studied sort of mineral deposit styles. However, saying that, for the major northern Cordilleran porphyry systems, you're going to need a lot of drill holes to actually come up with something, generally speaking. The bigger ones, at least 15 holes to produce an economic intercept in some of these systems. And in some of the bigger systems, like even Pebble and things like that, you're talking about tens to hundreds of holes before you actually hit an economic intercept. People are starting to use more advanced techniques to try to find these things. The ones that are at surface are pretty much found, so you have to expand your techniques on what you're going to use. You know, and these things include aster imaging, studies on zircon fertility, swirl analyses of clays, etc. And one thing that I'd really like to sort of emphasize is the identification of alteration element zonation. And if you look at this system here, you can see that you've got your porphyry copper center in here, but you also have all these distal elements that, especially in the Dawson Range area and in lots of places in Yukon, you can start using these elements to sort of target yourself into the main porphyry copper system. So I'm going to go real brief because I've got a lot of slides and not a lot of time, but basically the Cordillera is long-lived subduction, generally speaking, on the outboard of the margin, basically from the middle Jurassic and probably older. Underwent middle Jurassic to earliest Cretaceous sinistral transtension, which was followed by mid-Cretaceous to late Cretaceous dextral transpression. So right away, we're looking at a system where we have that motion, that transpressional and transtensional systems that develop these large crustal features that are good conduits for fluids and magma into the upper crust. Everything was followed by Paleogene to Oligocene and younger dextral transtension again, where you do get lots of extension and exhumation in the front part of the, in the foreland part of the Cordillera. And basically the whole system on the edge is switched to a dextral transform system with just subduction in just south of Vancouver Island and north of Yukon. I throw this slide up because I really like this slide. This is something that Mo put together quite a while back. But basically what it shows is that the central part of Yukon, which is shown here, has cooling ages as around 200 to 180 million years. And basically it indicates that the core of the Yukon, or at least the intermontane terrains, were at shallow crustal levels by the early Jurassic. And so this essentially is telling us that most of the plutons and magmatic suites and volcanics that are extruded and intruded into this area are fairly upper level sort of intrusions. And that's basically corroborated by the presence of these Cretaceous Paleocene volcanic rocks, preserving those paleo surfaces. Okay, so stepping back, basically, this is again looking at half of BC and into Yukon, and it's showing some of the major porphyry systems, world-class copper gold porphyry systems in British Columbia in the late Triassic, early Jurassic. Yukon Tanana, subject to extensive Cretaceous magmatism with copper gold porphyry systems in Yukon and Alaska. And then Wrangellia, which is often overlooked, includes Oligocene age magmatic arc southwest Yukon, preserving the high level porphyry mineralization that you need. You can see in red stars here, these are a number of the porphyry targets and porphyry occurrences that Strategic currently holds. And the blue stars are properties that are Strategic's option properties. Hopper by Cavu and 60 Mile by SOAR Metals. Okay, this is basically getting into what we're going to talk about now, really focus on is the central part of Yukon. These are the magmatic suites. These are basically all the magmatic suites that you find within this part of the Yukon, from the Paleozoic all the way down into the Paleogene. You can see there's quite a lot of plutonism in this area, which is obviously good for porphyry targets. What I'm going to do is start now at the Middle Jurassic. This is a figure from the Jurassic Atlas put together by the YGS guys. It's awesome. You guys, if you haven't read it, you should definitely read it. Starting at the Middle Jurassic Bride Suite, basically 172 to 166 million years, and includes the Tesman Cross and Pluton, the Michie, Mount Bride stocks, and the 4th of July batholith down here in northern BC. Pretty much bimodal, alkalic, oxidized, and reduced. And the Tesman Crossing Pluton in through here hosts pretty much the only known, at least, copper gold porphyry system in the Yukon. If we take a quick look at that, it's located right up in here, and the Mars property covers that Pluton. The Mars property is located roughly, 65 kilometers northeast of Whitehorse, and covers a multi-phase Pluton that's composed of syenite, monzondiorite as the central phase, and a border phase of monzonite to monzondiorite. There's been limited drilling at this property. However, there's the drilling targeted basically discrete veins, skarns, and a porphyry type mineralization, mainly at the Windy and the Andrew zones on the property. You can see some not bad intercepts of 0.24% copper and 0.17 grams gold over 14.7 meters. Won't read all those, but it's not bad intercepts for such limited drilling out there. You can see that this is copper soil laid over top of magnet aeromag data. We've got copper in soils up to 0.13% in soils, and it covers basically a central portion of magnetic high in the system here. The Windy Ridge and the Andrew zones were the ones I showed before, where most of the drilling has occurred. You can see some of the drill core that's sitting at the core library at the YGS. These are strongly altered monzonites. These are cut by biotite and chalcopyrite veinlets. You can see the K-feldspar potassic alteration associated with this phase of veining. And same thing down here, potassic altered monzondiorite, again with the biotite chalcopyrite veins, and it's cut by these later quartz veins into here. As I said, very limited work, very limited drilling, and is a really nice copper porphyry target. Moving into the mid-Cretaceous, basically there's 2 suites that are found in this area. The Kewaunee Ranges suite, roughly 125 to 108 million years in age, and the Whitehorse suite that Patrick touched on briefly earlier, around 115 to 109-ish million years. Both suites are calc-alkaline, oxidized arc magmas, and generally composed of hornblende, biotite, granodiorite, quartz-diorites, and lesser diorite and gabbros. The Kewaunee Ranges suite is a little bit more on the quartz-diorite and diorite side of things. Whitehorse suite intrudes intermontane rocks, and the Kewaunee Ranges suite intrudes Wrangelian rocks. Now, I suggested they're probably part of the same arc system, and I say that because I took a diagram from Don Murphy where he's reconstructed or taken the motion off of the Denali fault. If we look at that, this is a little bit cartoony, but it gets the point across. This would be your Whitehorse suite through here, and then following the mid-Cretaceous Plutons, et cetera, into Alaska. This would be your Kewaunee Ranges suite, and then that Soton suite in Alaska. If you restore that motion along the Denali fault, you can see that it restores somewhere around here. This isn't perfect, but it basically shows that there's a continuation of mid-Cretaceous magnetism all the way up through here, and basically younging from the southwest, southeast to the northwest in that direction. So the Whitehorse suite, Kewaunee Ranges suite, mid-Cretaceous mineralized systems that are associated with these are scattered through the central portion of Yukon. It includes the Idaho, Antoniac, and Pattison porphyry systems, the Brown and McDade, which Patrick just touched on. And then the Colony Ranges suite, there's the Nicky property, copper gold porphyry system that's been dated around 125 million years. And this is held by Strategic Metals. And I put this in possibility that mineralization at the Nicky is younger, and I'll get to that in a second here. So this is the Nicky property. It's located in this area just off the Alaska Highway, right near the Alaska border. It's hosted in variably altered biotite granodiorites, which those are the dated 125 million year old rocks on the property. There are lots of porphyry dikes that are cross-cutting these things that look quite a bit like some of the Oligocene rocks that I've seen in that area before. There's a large copper and gold soil and geochemical anomaly that overlies the ultra multi-phase intrusive suites with copper and gold values of up to 2750 ppm copper and 1590 ppb gold. You can see the main copper anomaly or geochemical anomaly here. It's at least, you're talking about 1 kilometer in length and probably 500 meters across. There's skarn mineralization associated with this, which is up in this part of the world. And chip sampling from that returned 11.5 grams gold over 2 meters. If we look at the pictures of what it looks like on the ground, you have very altered granodiorite in through here, sheeted-like veining and fractures that host basically limonite now, which used to be sulfides. Chip sampling from trenches just up above this with average grades of 0.38% copper, 0.36 gold over 6 meters, and almost 0.5% copper and 0.19 gold over 8 meters. 5 diamond drill holes to date have been completed at the Nicky, and it basically demonstrates that there's deep copper gold mineralization associated with phase of intensely altered crowded feldspar porphyry. Now, I highlighted this crowded feldspar porphyry because that's atypical of these mid-Cretaceous Kluane Ranges suite, but more in line with the younger sort of Oligocene age porphyry system or porphyries that we see in the area. So there is a possibility that Nicky is actually quite young, but it's hosted within those mid-Cretaceous granodiorites. The best drill result is 0.13 copper and 0.08 gold over 64 meters. But very limited amount of work has been completed at the Nicky to date. Okay, moving into the late Cretaceous, and I'm going to sort of blast through the mid Cretaceous because Patrick did a great job of going through it. Basically, I'm going to be talking about the Casino Suite and the Prospector Mountain Suite. I won't go into the geochemistry or the description because Patrick already covered that. You can look at some of the Casino Suite aged mineralizing systems, and they're all found within the central portion of the intermontane terrains and includes mineralization basically from 78 down to 72 million years in age. Again, we can see the properties that are held by Strategic in red stars, and they include the CD, the Alada, the Moraine, and the option property here is the hopper that Luke will be talking about a little bit later on. Prospector Mountain Suite, again, there's a 60-mile porphyry up and through here that Strategic has optioned out. And it probably includes the Connaught that Adam will be talking about. But there's a big cluster of these Prospector Mountain Suite sort of porphyry systems up sort of west of Dawson there. So we'll jump into the CD property, which is basically, go back here, basically about 20 kilometers away from the Claza area. It's located within the Dawson Range, as I said, about 20 kilometers southwest of Claza, and it's hosted within Casino age quartz feldspar porphyries. It's a huge property and covers more than just the porphyry. There's lots of vein mineralization up in this part of the world. But I'm just going to talk about the porphyry mineralization down in what is known as the Maloney area. These are the mineralizations hosted in feldspar porphyritic rocks that intrude basically the metamorphosed Yukon-Tanana country rocks. There's not a lot of outcrop, what makes it a little bit difficult to explore, but there is a little bit that has some interesting things. And essentially, those correspond to alteration, core of a potassically altered biotite magnetite zone, and spotty quartz sericite pyrite alteration that it's distal to that and slightly overprints it. And then the whole thing is overprinted by epidote chloride alteration in various degrees. We look at some of the geochemistry. This is copper on the left and gold on the right. You can see that there's highly elevated copper all the way up to 1155 ppm and gold values of 632 ppb. And it defines this 1200 by 400 meter soil anomaly within this Maloney area through here. There's a 3D IP survey over the easternmost part of the Maloney area and identified this really well defined chargeability high that corresponds with lows that have yet to be drilled. And you can notice that a lot of the gold mineral or the gold in soil anomalies are associated with some of these highs in the IP. I didn't show it, but you can trust me that lead and silver anomalies basically flank the core of this gold and copper. Basically, you find elevated silver and lead in through here and a little bit up in this part, suggesting possible distal mineralizing systems associated with this porphyry system. This is just a couple of the rock shots. This is a quartz biotite magnetite veins developed within that potassic core. And over here, you can see the overprinting epidote chloride veins. Here, it's overprinting some strongly quartz sericite and pyrite altered porphyritic rocks. Okay, this is jumping into, I'll touch briefly on the Alada property, which is located right in through here. Just a little bit south of Casino, a little bit northwest of the CD property. As I said, 50 kilometers south of Casino. It's within the Dawson range. There's very, very few outcrops, but where there is outcrops, you do get biotite granodiorite, quartz feldspar porphyry, and a little bit of monzonite. There's been very limited exploration and mainly just soil geochemistry and a little bit of geophysics. This is the regional map basically showing a huge sort of mid-Cretaceous white horse suite covering the entire area. The reason that we put it in this late Cretaceous suite, Casino suite, is the rocks that we see look very much like that late Cretaceous Casino and not more typical sort of hornblende porphyritic or the big hornblende crystals that you find within the white horse suite typically. The soil geochemistry is pretty phenomenal here. It's identified a 5 kilometer by 2 kilometer copper and gold soil anomaly. You can see it here. This is the copper and overprinted by the gold and through here. It also shows well-developed zonation of elements. So here you can really see the development of your zinc and your lead on the distal portions of this system. The core of the copper anomaly, again, sort of corresponds with magnetic low with a relative magnetic high shown through here. This is a really interesting project and really not a lot of work to substantiate this at depth. The lack of outcrop is really frustrating, but I think it's got a huge amount of potential. Okay, jumping down into the Paleocene to the Eocene, and this is basically covered by the Ruby Range suite, which is pretty much spatially at least one of the bigger batholiths or biggest sort of outpouring or volume of magmatic rocks that we see in the Southwest Yukon. Ranges in composition from diorite to granite, but is mostly a granodiorite The oldest phases of the pluton are strongly foliated to gneissic and found basically at that lower crustal level, or sorry, the lower base of the batholith down and through here where it's thrust over top of the Kelowna schist. The upper parts of the suite are massive, the variably porphyritic and often have myrolitic cavities showing sort of this upper crustal level of intrusion. This is sort of a bunch of chemical or chemistry plots. I wouldn't get into, or don't worry about the details too much, other than, you know, the suite is mainly paraluminous with more porphyritic phases trending towards metaluminous. They're high to medium potassium calc-alkaline intrusions, I-type, and basically form in these volcanic arc granites. There's quite a few mineral systems, porphyry systems, occurrences that are associated with the Ruby Range. The ranging basically, or sorry, found spatially quite close to one another. The one I'll be talking about is the Molloy, owned by Strategic Metals. It's a copper moly porphyry system that we've dated at 57 million years of age. It's located approximately 100 kilometers northwest of Haines Junction, and it's underlain basically by the granodiorites, quartz monzonites, and quartz feldspar porphyries of the Ruby Range suite. Prospecting in the area has returned rocks grading up to 8.72% copper, 845 grams silver, 1.47 moly. I shouldn't say 1% gold. That would be crazy. And 3.51% tungsten. That's 1 gram gold. Porphyry type veining is found throughout the property, including quartz magnetite and quartz sulfide veins. Geochemically, copper and soil geochemical anomaly, 3 kilometers by 3 kilometers over the main ridge, and another one over this plaster ridge Talbot Cirque area in the southeast part of the property. Copper anomalies within the copper anomaly, gold, silver, moly geochemistry is also very strong, and they both have very similar. Both have smaller clusters of tungsten, tin, and zinc. The Casino deposits, soils, this is a while back, but basically showing very similar sizes for both of these systems. Some of the rocks that you see from basically the main ridge area, these are quartz and quartz magnetite veins with minor sulfides developed within the granodiorites. Here we got quartz chalcopyrite bornite veins developed within some of the finer grain biotite feldspar porphyry, and strong sericite clay alteration within sheeted veins and sheeted fractures that locally host abundant sulfides. This is again a system that has seen very little drilling and has a lot of potential at surface that needs more work. Moving into the Oligocene to Miocene, this is basically the Cope suite and the Wrangell suite, and these are intruding into the insular terrains, as you can see in through here. The Tecope suite is composed of biotite granodiorite, granite, and minor diorite. Wrangell suite is characterized by hornblende granodiorite, porphyritic granodiorite, and subvolcanic, lots of subvolcanic intrusions. Geochemistry shows a general calc-alkaline signature that basically progresses into more alkaline signatures the younger you get into the Wrangell suite of intrusions. Mineral occurrences associated with these suites there's not a lot of them. There's a couple, there's the mint, the corky, and bat, and the Wrangell. I'll be talking about the mint, which is owned by Strategic Metals, and the bat down in this part of the world. First, the mint, which is up in through here, just a little bit south of Beaver Creek, right along the Alaska border. So it's located at approximately 30 kilometers southwest of the Alaska Highway, and it's underlain by this complex Oligocene to Miocene aged volcanic plutonic complex along the Canyon Creek area and through here. It's characterized by multiple different phases of moderately to intensely altered granodiorite and feldspar porphyry. Some of the new mapping from this year identified a zone in the Upper Canyon area of intense porphyry style veining and alteration that accompanies gold, copper, silver, moly mineralization in the system. Lots of A and B veins associated with alteration. These are overprinted by cooler temperatures or D veins and higher alteration assemblages, possibly suggesting that the system has actually been telescoped. Soil sampling to date has outlined a 1,100 meter by half a kilometer strong, strongly anomalous gold anomaly up to 3,400 ppb with broad zones of elevated gold, copper, moly values. In 2012, 5 holes were actually punched into this and evaluated widely spaced geochemical anomalies. Some of the highlights in M1203, which is located right in through here, basically 2.04 grams gold over the entire length of the hole at 331.74 meters. And it terminated in half a gram gold over 53 meters. M1205, which is over a kilometer, just about a kilometer away, gave 0.244 grams over 45.53 meters. So it's a big system. We don't completely understand it, but it's looking really, really good, especially when we look at the zone, the Upper Canyon zone that we found last year. You have A and B veins cross-cutting later stage D veins, which are cross-cut by later stage D veins within altered granodiorites. Here we do have sheeted A and B veins within strongly altered granodiorite. And then this is a close-up of some of those D veins with galena sphalerite hosted in late D veins. A lot of these B veins and A veins have chalcopyrite and pyrite associated with them, and shows a significant amount of copper mineralization at surface. Okay, moving down here to the BAT, down towards the British Columbia border. It's located approximately 60 kilometers south of Haines Junction, 20 kilometers west of the Haines Road. It's underlain by Paleozoic rocks of Rangelia and intruded by this late Triassic Mount Beaton Suite and numerous dikes and plugs of Oligocene and Miocene porphyritic rocks. Very limited amount of work has been done on this property, although we've found very high-grade copper, gold, and cobalt that are associated with quartz and quartz carbonate veins. And some of the samples grading up to 19% copper, 1.4% cobalt, and almost 4.5 grams gold. This is all the soils that have been completed to date on the property, which is less than 20%. But there's an anomalous copper at the main ridge, the MS, and the boulder zones in through here. This is a picture of the main ridge. You can see some of the vein hosted mineralization here. 2.7 grams gold, 0.2 copper and cobalt. Up in this area, 4.5 grams gold and 0.5% over a meter. And in this area and through here, 1.4% cobalt and 1.43 grams gold. So lots of mineralization in this area. We did do some detailed mapping this summer that we're putting together. And so we do have a little bit better understanding of what is happening in this main ridge. The mineralization of the BAT, this is looking towards the basically the northwest. This is the main ridge. The picture was shot taking sort of the backside of the main ridge here. Now we can see how big this mineralizing system is from the main ridge to the boulder zone. Some pretty amazing numbers here at 19% copper, 4.1 grams silver, 18% copper and 40 grams silver. And then this 3.6 copper and 1.28 grams silver. What we think is happening at the BAT is that these veins are associated with the upper levels of a deeper seated porphyry system. And we see that because we see several of these porphyritic dikes and stocks on the property that are cut by these veins and themselves show localized epidote and chloride alteration. We're not entirely sure, but I think this is our working model at the time, or right now. More work needs to be done, but it's an incredible system. I really, really like the bat. So in summary, basically Southwest Yukon is host to lots of porphyry style mineralization of several different ages, basically all the way from the Middle Jurassic down into the Miocene. And I think there's potential to find new exposures and new systems because of the lack of outcrop in this area. I think we just have to develop new techniques. And basically that's, we can do that using these new techniques. Some of the stuff that Warwick was talking about could benefit us immensely going forward. And finally, the strategic holds properties that span basically a broad range of environments and geologic time, as I've shown within both established porphyry camps and frontier districts. And I think that's it. Thanks very much for listening.
Thank you, Steve. Any question you have for Steve, please put them in the chat or the Q&A box, and we'll come back to this at the end of the session. So we'll move on right away to the elephant of the Dawson Range. Carl Schultz is going to tell us about the advanced exploration at Casino this past year. Go ahead, Carl.
Okay, well, first of all, I'd like to start with thanking the Yukon Chamber of Mines for hosting this speaker series, and also asking me to be a speaker in it. I'm very pleased with that. My name is Carl Schultz. I am a senior project manager with Aurora Geosciences, and today I'm pleased to give you this talk, Progressing Towards Production, Advanced Exploration at the Casino Deposit. Casino, just for openers, is also held 100% by Western Copper and Gold Corporation. Okay, just forward-looking statements. I'd also like to start with just stating that the casino property is located within a traditional to also impact the Little Salmon, Carmacks, Trondequetchin, Kwani, and White River First Nations. So I just wanted to point that out. And now we'll go into the sort of synopsis here. The 2021 diamond drilling program focused on geotechnical and metallurgical testing and resource confirmation drilling within the deposit area. And it also included some exploration drilling outside of the pit shell. And we'll start with just where is Casino? I think most of you probably know, but especially if you've been watching the talks from before, it's about 300 kilometers northwest of Whitehorse. It's about a 1 hour flight with a Dornier or a Caravan aircraft. It's also 150 kilometers southeast of Dawson City, Yukon, so we can use that in case of any kind of medical emergency, and also for some amount of supplies, infrastructure, that sort of thing. And about 415 air clicks from year-round port facilities at Skagway, Alaska. And we're about 25 kilometers from the southeast of the Coffee Project. So we'll go from the where to the what. Okay, well, you probably know this too. It's one of the world's largest porphyry copper gold moly deposits. It's 100% owned by Western Copper and Gold. In July 2020, a resource update indicated that the mill resource and the heap leach resource estimates, which are separate estimates, have been significantly increased. And here's just some stats. These are worth reading out. The current measured and indicated mill resource is now estimated at 7.6 billion pounds copper, 14.5 million ounces of gold, and 811.6 million ounces of moly. And the additional inferred resource is 3.3 billion pounds copper, 6.6 million ounces gold, and 323 million pounds moly. Just you probably all, most of you know this, but we're not allowed to combine measured and indicated resources with inferred resources, but inferred resources are still something you can report under 43-101. On top of all that, we have heap heap leach measured and indicated resource base at 167 million pounds copper, 1.8 million ounces gold, and 13.3 million ounces silver. So this is truly a colossal deposit. Just a few more facts here. 25-year open pit mine life is proposed. The first feasibility study was completed in 2013, positive results. There's an updated study on that commenced late last year. It's underway. Environmental assessment application was submitted in January 2014. The property includes a high-quality airstrip capable of landing Dornier caravan. It's important. Property is connected currently to barge landing along the Yukon River by a 22-kilometer access road. And the property now includes the Canadian Creek property, which was acquired in 2019 from Cavu Resources. Here we just have a claim map with the casino property as it relates to the Coffee Creek property of Newmont and the Betty property of White Gold. So this is the main block here. This is our open pit. This is our heap leach area. Proposed heap leach area. There's really not much there now. The current camp is also where the mill facilities will be. The tailings management facility is a bit to the south along Casino Creek itself. We also, our claim block also extends along the access road to the river, and the claim block also extends along the proposed access road from Carmax. And there's a Canadian Creek block just to show the the expanded size, and so it's contiguous. The road to Casino, or the proposed road Casino, there's actually a good road for 4x4 vehicles that goes as far as Mount Freegold. Then there's a trail that goes from there to roughly the Sonora Gulch area, which is about 50 air kilometers to the east. And from that point on, the road has to be constructed. Just a little bit of geology. The deposit is within Yukon-Tanana terrain, which is an accreted terrain that's on the southwest side of the Tintina Trench, situated within the northern part of the I'm just going to move this here for a moment. For the 104 million-year-old Dawson Range batholith. It's part of the Whitehorse suite of intrusives, and this has of course been intruded into the Paleozoic rocks of the YTT, mostly metasediments and metavolcanics. So this is the Dawson Range batholith here. This is truly an enormous batholith. It extends from roughly Sonora Gulch, which is about 50 clicks east, and goes for about 300 kilometers in the north-northwest or west-northwest direction, well into at least as far as the Northway Junction area of Alaska. So if anybody's ever driven to Fairbanks and knows where that is, you can get an idea of the size of it. It includes rafted blocks of Paleozoic snowcap assemblage metasediments, which are shown in sort of this bluish color, and also Sulphur Creek, the Permian Sulphur Creek meta-intrusive rocks, which are shown in green. So we have a number of inliers. And here we have essentially a sketch kind of the deposit area itself. It's centered on the late Cretaceous patent Porphyry suite. And intrusion, I should say. And this is a member of the Casino suite, which is it's been dated at about 74 million years of age. So that fits in very nicely with the talk from Patrick earlier on, and also from Steve Israel. So thanks for the supporting documentation earlier this morning. Excellent talks. That's surrounded by what's called the intrusive breccia. And this is essentially the host for the highest grade mineralization, and this makes perfect sense. The patent porphyry itself, it's dacitic to andesitic, feldspar porphyritic, multiple phases, but all of them have varying amounts of feldspar porphyries within it. So it's been intruded into the White River granite diorite and has caused brittle fracturing, and of course that creates structural preparation for placement of fluids emanating from the stock itself, and essentially this is where we get our best grades. The patent porphyry itself is also mineralized and is considered part of the deposit, but the grades are slightly lower. Marginal to that, we have two units of MX explosive breccia, a large one to the west, which kind of truncates the property. These are a little bit younger, so that makes sense, and a smaller one to the southeast. Essentially, the matrix, these are unmineralized, but if they have caused brecciation of mineralized host rock and there's abundance of class, we do get some amount of mineralization and some elevated numbers in our core, but they're essentially not part of the deposit. And here we have a rough estimate of the deposit outline. And a bit of a primer on the metallurgical zones. There's 3 of them: leach cap, supergene, enrichment zone, and the hypogene. The leach cap was formed because this area is unglaciated. And with it, as such, it's had several million years worth of time for meteoric fluids to percolate from the leach cap into the underlying supergene sulfide or supergene zones. So the leach cap is more or less devoid of copper. It does return some weakly anomalous numbers, but it's not terribly enriched in it. The gold ions are a lot less mobile. So they, for the most part, stay behind, although there's some transport as well. So the leach cap is still gold enriched, which is why there's going to be heap leach program component to the extraction operation. Supergene sulfide is essentially the original deposit, which is of course disseminated porphyry style mineralization, but also superimposed with essentially secondary copper bearing veins, mainly chalcocite plus or minus some bornite, even plus or minus a little bit of native copper here and there. The grades can be up to twice as much as it is in the underlying hypogene zone. And the hypogene zone is essentially the original deposit. That's been essentially unenriched. The supergene sulfide also, there's a minor amount, about 10% of it is actually supergene oxide. So you get copper oxide and hydroxide minerals, a lot of azurite, malachite, easy to spot. And the supergene sulfides is 90% of it. So as I said, vein style mineralization superimposed upon porphyry style mineralization. A little bit of a recap on last year's talk. Last year in 2020, we explored 3 target areas: the gold zone, which was hypothesized due to some high-grade intercepts in 2019 work; the north zone, which is actually considered to be possible second porphyry center; and the Canadian zone, which is mineralization outbound to the west of the main zone. There's really not a zone per se, so it's just considered part of the deposit itself. The north zone, there's no other porphyry center, but the grades are fairly good towards the southern part of it and gradually diminished to the north. Canadian zone, we had some joy towards the north end of it, and the southern end was pretty much dead. This area here is also an area of curved placer excavation by Cavu Mining, and they get some nice coarse gold out of it. We did about 12,000 meters and 49 holes, but we did not significantly expand the deposit size from that work. Now we'll get into the 2021 work, and as an opener, the Rio Tinto early in the year provided a $25.6 million strategic investment to acquire an 8% interest in the Western Copper and Gold, basically in their stocks. So that was a nice way to start the year. And the 2021 program, therefore, was tailored towards establishing viability of the project, and it focused mainly on metallurgical and geotechnical characteristics of the deposit. And we also, as I said before, began work on a feasibility study. There were several major components. One was the drilling, and that itself comprised 4 different subcategories. There was resource confirmation, basically showing that it is indeed there, metallurgical drilling, geotechnical drilling, and exploration drilling. And we also scanned a great deal of core with using the geologic AI portable facility by Enersoft. That's very interesting. I'm going to get a little bit more to that in a minute. Soil geochemical sampling across the majority of casino property was done. And we also did some additional geotechnical drilling that's separate from this drilling. And that was to determine ground conditions for planned tailings dams, heap leach, and milling facilities. So more like pure geotechnical work. So just do a quick rundown on what we did. 5 holes for a little under 1,500 meters for resource confirmation drilling. Metallurgical drilling, 3 holes for 1,000 meters. Geotechnical drilling, 8 holes for just under 2,000 meters. This is deposit area drilling. And exploration drilling was 6 holes for about 1,600 meters. This is a basically a satellite image that shows the location of the holes. Metallurgy, resource, and geotech holes all were focused in and around the deposit area, mostly on the east side and sort of in the southeast side. But we also did several holes just a little bit outbound to the east of the actual deposit outline. And then we did 3 holes. These are exploration holes that were predetermined to test for any outlying mineralization. Our soil program actually did reveal several copper anomalies. So we drilled these 3 holes here, outbound as more of a pure exploration play. The geotechnical drilling also included downhole televiewer followed by piezometer surveying. And televiewer surveying includes downhole optical, acoustical, and gamma ray surveying. And the optical just provides us with a visual of the essentially stratigraphies that go downhole. The acoustical is more for structural characteristics and also to some degree for essentially mine safety to make sure that the rock is sound or not sound. And gamma ray surveying, that's a survey where it measures low levels of radioactivity, and variations in that can help determine lithology. And the piezometer surveying was designed to determine groundwater conditions. The piezometers are still in there and will remain there for an indefinite period. And we did these surveys on all of the 2021 geotechnical holes. Here we have, this is a piece of hyperspectral imagery from the 2021 survey. This is actually our core from Geologic AI. The upper part can help show the rock types, or mineral types, I should say. And the bottom part is more the alteration. So it's very, it's very informative. We've got also, it also takes LiDAR imagery of all the 2021 surveys. What is interesting is I always thought of LiDAR as something that you do for topographic evaluation, very detailed topographic surveys, but it can also be done with core. We also use triple tube coring procedures and for all the resource confirmation and geotechnical holes. And this is just done to improve recoveries and preserve other geotechnical data. Some of the core is fairly crumbly, so this really helps keep it together. And the geotechnical drilling targeted proposed heap leach and tailing facilities was also triple tubed. So that's the additional stuff on top of that. I'll get to that in a moment too. This is the Anersoft machine. It's a pretty interesting machine. We had to fly it in by using, I think, a 204 or something. Oh, actually, a Bell 407. And this thing can scan, with all those surveys that I mentioned earlier, can scan 2 pieces of 4-foot-long core boxes with 4 Rosso NQ or NTW core. It can do it in about 12 minutes. So we just fed it core basically all summer long. We scan about 40% of all the historic core, mostly the 1992, 1994 stuff, and the core from the 2008 to 2012 programs. We did this year's or 2021 core and some of the 2020 core. And we scanned 48,600 meters of the core, which is 48.6 kilometers. So you can imagine the work that was gone into it. You can also see if that's roughly 40% of the historic core, minus the more recent stuff, there's still an awful lot of core remaining, and obviously an awful lot of drilling has occurred. The surveys will include chemical analysis by XRF, alteration, mineral and sulfide identification, and this by hyperspectral analysis, textural mapping by LiDAR, and also high resolution photography, and that's really useful for RQD determination, which basically shows you the competence of the rock that you're drilling. So our soil geochemical program, 2,500 samples, mostly east and south of the property. The objective was to find other porphyry centers or other targets of interest. And the soils were taken along a 200 meter by 200 meter evenly spaced grid. And all soils underwent detailed description. And we also had a portable XRF machine, just a little handheld ones, probably many of you have seen, and a small container, what we call a containment unit. We called it the barbecue. And we passed all of our soil samples through this to get various elements in advance of the actual analysis. And as you all know, that's been quite slow this year, just for a number of reasons, are quite obvious. There's our grid. Each one of these dots is 200 meters in cardinal directions from any other dot, so it's huge. It was a vast area, had to be highly supported. There's the actual deposit area for scale. About halfway through mid-August or so, we made some plots, preliminary plots. These are not complete. This area here was only just starting to get done. But plotting copper results from an XRF showed 3 distinct anomalies. We also did plots for copper, molybdenum, arsenic, lead, strontium, and also ratios of copper to zinc and copper to manganese. And also existing geological data was compiled. It led to establishment of 3 of the 3 drill holes I mentioned before, and we were able to drill them late in the year. This is the arsenic plot. We have plots for all of those elements I described, but I just included arsenic here. And that revealed a very pronounced east-west trend of fairly strong values. Starts at 186 and goes up from there for the purple ones. And another trend here. And this trend here is also intriguing because it's mimicking the topography, the stream drainages, which may be mimicking the stratigraphy locally, or at least the structure. These may represent future targets for bonanza style or epithermal style auriferous quartz veining. So it's a pretty intriguing survey. So I'll just go on this quickly in the other geotechnical work that was done by Knight Piso Consulting. 7 short holes were completed to test overburden, permafrost, and bedrock conditions at three locations. 2 were drilled along the base of the proposed dam for the tailings management facility. 4 holes were drilled along the proposed heap leach facility. And there's 1 hole was drilled at the proposed plant site, which is exactly where the camp is right now. And the hole is actually collared right next to some of the 1990. A little more in the sketch, but of the proposed mine and milling workings. This is the actual heap leach. Pardon me, this is going to be the pit. And it's of course the deposit area. This is the area that's going to be heap leached, and it's just about the same size. This is the proposed plant site, so now you know where the camp was. The airstrip is right next to it, and of course that will be gone, as will the camp. The tailings management facility is essentially bordered by essentially a dam. And this is not like Hoover Dam. It's not a vertical dam or semi-vertical dam. It's actually a very gradual slope. The extent of the slope goes down its base here, right at Casino Creek. And that's about 1 kilometer worth of slope, and it's about 280 meters worth of rise from the lowest point to the highest. This area is a tailings management impoundment itself. There'll be a little bit of water, mostly over here, but essentially it's mostly a tailings impoundment. It's not a big water dam. The new airstrip will be here, again, along the proposed new road. And the new campsite will be there in this area here. We have a nice view, that's for sure. This area here, this is just a detail of the proposed tailings management facility to the dam site. We did drill 2 geotechnical holes for it. And we drilled 4 other geotechnical holes in the proposed area, 3 along the basal area of it, and 1 along one of the benches. So we've got more to do next this coming year. There's still some more geotechnical drilling to go, but we've already made a start on it. And that is essentially my talk. I wanted to list the contributing suppliers and service providers that made this program work. It was a lot went into it, and a lot of significant contributors went into it. Local companies, And I'll just leave this up for maybe 10, 15 seconds. I won't mention any in particular, but you can see them.
Thank you, Carl. Good
Well,
presentation.
thank you. There's my final slide. And feel free, I'll be around, of course, at the question and answer, and there's also casino mining. Thanks very much.
Thanks a lot, Carl. So we're halfway through our program this morning, busy program, and so we'll move right on to the western edge of that Dawson Range belt, quote unquote. And Adam Coulter from ATAC Resources will tell us about their work at the Connaught property. Go ahead, Adam.
Thanks for tuning in, everyone, today. Title of my talk is a new copper moly gold porphyry discovery at the silver lead Connaught property. I'll be making some forward-looking statements. Quick overview, I'll give a bit of an introduction to the project. We haven't talked a lot about Connaught in the past, and then we'll take a bit of a step out, look a little bit at the regional geology, and then get into really our results from this past summer, which was some trenching, looking at a bit of historical core, a little bit of geophysics and some geochemistry, and then what we plan to do next year in 2022. So if you're not familiar with ATAC, we've got 4 main properties. Most well known for our Raka Gold project, which hosts the Osiris Carlin type gold deposit, 1.7 million ounces at 4.2 grams. And our Tiger oxide gold deposit, which is an intrusion-related system, almost 500,000 ounces at over 3 grams. But today we're going to be talking about our Connaught property over here, just west of Dawson City, near the Alaska border. So it's a 137 square kilometer road accessible property, located in the headwaters, immediately above the 60-mile Placer Gold Camp. Which you can actually see in this figure here, just up to the northwest, which has produced over 560,000 ounces of gold. The property hosts and has been mostly explored for these silver lead plus or minus gold, copper, zinc epithermal veins. Various rock samples across the property have graded up to over 4,000 grams silver, almost 80% lead, 10 grams gold, 7% zinc, almost 2% copper, and 0.12% moly. The number 1 and number 3 veins are mined in the 1960s and 70s, which you can see on the west side of the project over here. The grades of that mining was actually 2,200 grams silver, 60% lead, 1 gram gold in 240 tons. And this past year is really the first exploration program looking for porphyry copper in the area. So this is really, everyone's seen this Silito model before. This is the general thesis for why we did that. The property, again, mostly explored these sub-epithermal veins. And this past year really wanted to just look to have a look around the project and see if there is any porphyry copper potential. So to get there, we consolidated the land package in 2020. This past year, we wanted to advance this concept right through to drill decision, and we decided to do a maiden drill test next year in 2022. So taking a step out, we've been hearing a lot about this geology through other talks today, but this is a really nice overview done by Matias Sanchez and others in 2014. And they've done a good job of tying together this bigger picture regional geology between Alaska and Yukon, along with their called the 60-mile Pika Fault. Here's our Connaught project here. Just to the southwest across the border is the Taurus Bluff Porphyry, owned by Kennerland Minerals. We think that's one of the best analogs to what we're seeing so far at Connaught. This structure, the 60-mile Pika, is 150 kilometers long, a northeast trending sort of arc-oblique structure that focuses a variety of porphyry skarn and epithermal occurrences along its extent. And the Connaught project might also sit at the intersection of this 60-mile Pika and the Mount Tyrrell Thrust Fault. So getting a bit of a look at the project here, these yellow lines are the roads throughout the property. The red lines you see here are all of these different silver lead veins. There's been a bit of historic drilling of these white dots across the project, really just targeting a handful of these different epithermal veins. We'll jump right into the geology here. First, these pink blobs you see are this late Cretaceous prospector mountain sweet rocks, which is really the main host rocks we were looking at this year. You can see there's 4 mapped main intrusions across the property. There is limited exposure here, so there might be more. Just on the east side of the project here, there is a bit of mapped Carmack Sweet late Cretaceous, thought to be sort of near Coeval, I believe, with the Prospector Mountain Sweet volcanic package. Down to the southwest, just off the edge of the property, there's some of the mid-Cretaceous White Horse Sweet monzonites intruded there. So a lot of late to mid-Cretaceous activity going on here, intruding into mostly the Finlayson mafic volcanic package here. There are a little bit of marbles noted around, and off to the southwest side of the project here is the Grass Lakes Ogden gneiss. And up on the north side here, there is a package of the Klondike schist. The main structures you see cutting across here, cutting through the middle, this northwest trending fault here might be the extension of that Mount Tyrrell thrust fault I mentioned earlier. And then this northeast trending structure you see in the very northwest side of this figure is the 60-mile Pica structure, and also where the 60-mile placer gold camp is. This is just a quick look at the Yukon-wide total magnetic intensity, and you can see this broad sort of east to west trending mag high cutting through the project that likely correlates quite well with the Prospector Mountain Sweet intrusions. And this is some higher resolution ground magnetics and meshed in VTEM magnetics that we did this past year. And it really, you can just see that correlates quite well with that broader Yukon mag. You can just pick out some more features within that. You'll note this kind of interesting magnetic donut feature down here to the southeast of the property. So this is looking at copper soil. We've got almost 13,000 soils across the project now. And we've identified 4 target areas that we believe have some potential for porphyry copper systems. And target area A has really spent most of our attention this year, and really actually just a really small subsection of target area A, sort of in the middle of it. Looking at molybdenum in soil, you'd see, again, quite nice coincident copper and molybdenum in target area A, C, and D, and B being kind of flanked by molybdenum in soil. So zooming into where we worked this past year. So again, that target area A, you can see here, you can see these 10 green lines. These are the 10 trenches that we dug this past season, and we'll get into the geology and of that shortly. And looking at the molybdenum. So again, the reason we started here actually is that this area has some of the strongest copper and molybdenum response, and the hundreds of ppm copper throughout this trenching area and tens of ppm molybdenum. And there's a notable lack of any other elements there, such as silver and lead, that we do see shedding off these epithermal veins up to the north. And just for scale and context, I threw on the Casino deposit footprint we've seen in Steve's talk earlier and Carl's. So these are really just putting this in here to show that the scale of these anomalies. They are quite large on the multiple kilometers. Looking at the magnetics, target area A is sort of in this moderate magnetic high, whereas target area B, you see this strong magnetic high in the middle, surrounded by this obvious magnetic low. So zooming into the trenching. There we go. So these are the results we put out. All of our results are out now. Some of the highlight results are Trench 21E here. Some of the best results actually are up to the northwest here, and this is still open to keep expanding. Trench 21E, yeah, 724 ppm copper with 139 ppm molybdenum over 84 meters. Big note here is that this is an unglaciated environment, and we do expect to see copper depletion due to leaching. And we'll see some pictures of some of those leached rocks in a moment. And then that across trench there, Trench 21D, 467 ppm copper and 150 ppm molybdenum over 93 meters. We're really excited about this northwestern area. You can see a couple of the grab samples up to 1.38% copper within these trenches. Yeah, we'll get into a couple of the rock pictures of these samples in a moment. So quick summary of the geology that we've seen so far. This is all still pretty early days, but these Lake Cretaceous prospector mountain sweep rocks, we've observed multiple phases of intrusive stocks, dikes, and breccias, including an equigranular quartz monzonite, a quartz monzonite porphyry. There's a quartz latite phase and an intrusion breccia. Mineralization, we've seen a lot. In all of these trenches, we saw disseminated and fracture-coated malachite, tannerite, and azurite within all of the different rock types, probably as a secondary mobilization of some copper. We see disseminated chalcopyrite, pyrite, and bornite, plus or minus some malachite within the intrusion breccia. We do see some disseminated malachite, tannerite, and chalcopyrite and pyrite within that quartz latite phase as well. Alteration, as you can see in this picture here on the right, you see this kind of orange staining. You see a lot of secondary iron oxides. That tells us there was a lot of sulfide there at one point in time prior to the oxidation. So a lot of the trench material is this very friable orange, yellow, brown mix of iron oxides. We were calling a lot of it just like a quartz monzonite sand. Locally, you do see a high abundance of sericite and pyrite in some places, up to 10% throughout the trenches. There's localized silicification and some quartz staining. So this is just looking at the grade distribution within these trenches. Again, you can see some of the nice results in trench 21 D and E. This is looking at copper. Everything in red is over 0.1%. And you can see some nicer intersections of over 0.1% in a couple of the other trenches as well. Looking at molybdenum here, again, we do see some nicer elevations up to that northwest side here, possibly some sort of east to west trending mineralized structure here in between trenches 21 D and E. Molybdenum doesn't weather like copper, so we're going to be using molybdenum as a vectoring tool going into the drilling next year. So if we take the average value of all these trenches you see within this circle, this 450 by 250 meter area, it's 479 ppm copper, 51 ppm molybdenum, and 1.16 grams per ton silver. And these are still open up to the north and to the west. And then I just pulled out the updated 2020 resource from Casino that we just heard about with Carl. And the reported average leach cap grade is 300 ppm copper, 0.25 grams gold, and 1.9 grams per ton silver. Unfortunately, we aren't seeing a lot of gold so far in this, but we are seeing a nice strong elevation in the copper, similar to and potentially above the Casino's leach cap. So getting into a bunch of rock sample photos. We just got some of these back actually yesterday, some of these polished samples. This upper right here, this is what we are calling the quartz latite unit. This grades 1.38%. You can see a bit of malachite staining on the rim of this sample. This overall sort of really bleached white appearance, loaded with a lot of different feldspars. The black mineral you see in there is this secondary copper tannerite mineral. Up in the top right, similar looking unit, you can see a bit of azurite staining in the middle. This contains some disseminated chalcopyrite as well. Bottom right here, we see this intrusion breccia phase. This has chalcopyrite, some pyrite in it as well, and we did find a bit of bornite in places. And then in the bottom right here, this is more of the regular sort of quartz monzonite. You see a quartz chalcopyrite pyrite vein running through the middle of it. This is 0.17% copper. And you can see a bit of malachite staining on the top end of that sample there. This is another shot from the field of that quartz latite. You can see the disseminated chalcopyrite pyrite and secondary tannerite malachite on the outside of this sample. So same one we saw on the top left of the last figure. This is actually from our very first trench. This is an exciting find. Going through that first trench and seeing a lot of malachite and tannerite within a really sort of leached, oranged, oxidized quartz monzonite. This is fairly common we see throughout a lot of the trenches. Really this fracture-coated secondary malachite, which again, to me, seems like some sort of redistribution of secondary copper oxides throughout the entire target area. So it's an interesting sample we picked up actually while flagging in the trenches this year. You can see this sort of brick red iron oxides. This is one of the better coincident copper, 0.25% copper and molybdenum samples with 205 ppm molybdenum. If anyone has any ideas or thoughts on the sample, I'd be curious to hear them. But this sort of iron oxide potentially was some sulfide veins running through this quartz monzonite. This is from the highlight trench out here, trench 21E. We saw a lot of this. This is actually that breccia phase. You can see in this picture here a lot of sericite and pyrite in this sample. This grades 0.13% copper and 547 ppm molybdenum. Just throwing this in here, this is actually not from the trenches, but a kilometer up to the northwest. So something we'll need to follow up next year. But this is actually a sample that grades 0.24 grams gold, 300 ppm molybdenum, and 300 ppm copper and 335 ppm molybdenum. We'll have to go trench and get a better look at next year. But this is showing us that there is potentially some gold bearing phases that we haven't recognized yet and didn't explore this past year. So we'll get out and get our eyes on this, follow up on this next year. And this is a sample from one of the magnetite skarn occurrences just off to the west side of the trenching area. This is 0.5 gram gold and 0.12% copper. We've got a quick look at some of the historical core in the area. Again, there is a handful of holes targeting some of those epithermal veins just to the north of where we trenched, and getting our eyes on some of the alteration and veining. We did see quite a bit of quartz pyrite veins with, you can see some of these alteration halos, muscovite, bit of chlorite surrounding some of these D veins. We did about 40 kilometers of ground IP this year over this target area A. And what you can see here, this is just a plan view looking at the chargeability. See some elevated chargeability kind of surrounding the trenching, which we interpret might represent a pyrite halo. Cored by a resistivity low, sort of immediately underneath the trenches. So at the 50 to 100 meter depth slice. As we move deeper, getting into the 300 to 500 meter level, we see similar response in the chargeability, a couple of point quite high chargeability response, and then this quite interesting strong resistivity high immediately underneath the trenches. So we'll have a peek at one of the sections through here. So we'll look at this cross section, or about to look west across it. So this green line here represents the surface expression of the trenches. We're looking at chargeability right now. We do see sort of 50 to 80 meters below the surface is the chargeability is starting to pick up. And we wonder if this is potentially some supergene enrichment or getting into some of the hypogene mineralization immediately underneath that. This black line here represents the edge of the mag high, and we interpret to be sort of the edge of the Prospector Mountain suite. So this is likely actually the host rocks out here to the south. So you see some strong charging. I think that this might actually be some of the basaltic host rocks to the south. If we jump next over to the resistivity, you see this interesting strong resistivity high. This is the highest resistor in the survey area, sort of right underneath those trenches, coincident with some charging. So this is a nice target we're going to want to check out next year. Running out of time, so quick mention, we did some shortwave infrared analysis, trying to hone in this pretty limited outcrop here. But as expected, we did see a decrease in the overall aluminum hydroxide scalar values as we worked our way closer towards these trenches. And interestingly, a strong decrease in values up towards this magnetic donut feature here into the southeast. And then unsurprisingly, the hyperspec returned a lot of white mica and variety of iron oxides in these trenches, just kind of supporting our field observations. Quick couple geochem plots here. There's some great work out by Scott Halley on porphyry copper geochemistry, and all the samples from the trenches here show a strongly oxidized magma with high water content, which is prospective for porphyry copper. Quick shot of some old core here, some malachite on the right. Another diagram from Scott Halley. This is just kind of supporting our hyperspectral results. You can see a lot of these quartz monzonites plotting towards this muscovite, indicating possibly a phyllic alteration, whereas that quartz latite unit is actually plotting up more towards an advanced argillic alteration, which is kind of interesting, seeing a bit of a difference in those two different rock types. So tying this all together, what we do see here is a strong copper moly response in the 10 trenches that we dug, considering this is an unglaciated environment. I think we're looking at broad phyllic alteration, seeing the D veins, an abundance of pyrite over 10% wherever the rocks are fresh, and mostly iron oxides wherever they're weathered, indicating that maybe we're in the pyrite halo. We've got a high abundance of white mica and vast majority of our samples. We've got nice coincident geophysical anomalies, low aluminum hydroxide scalars, a large 2 by 1 kilometer casino-sized copper moly soil anomaly, prospective host rocks from a geochemical perspective, and this area is generally speaking just quite underexplored. So next year, we've locked in a rig with Midnight Sun Drilling, one of their big RC rigs. So we're going to punch a bunch of holes underneath these trenches, testing these geophysical targets, that gold bearing phase, and maybe a couple holes around that gold copper magnetite skarn. We'll prospect and trench target areas B, C, and D. We've got some zircon fertility and age dating underway. Shot here on the right with Scott and Warwick of the YGS from this past summer, checking out some of the rocks. I want to acknowledge that we're working on the Trondheim traditional First Territory, and shout out to Ground Truth Exploration, Backcountry, Horizon Heli, Absolute Mechanical with the excavator, Scott Geophysics on the IP and mag, Mackenzie Petroleum out of Dawson, ALX at a Whitehorse for the supplies, and Kelsey with Anik Expediting for making it all happen. Thank you.
Thank you, Adam, for a good presentation. Again, just load your question in Q&A and chat. We'll come back to this shortly. Now we'll move for the next two talks to some of the older mineralization in the district, and we will first go to the latest activity at the Minto Copper Belt, Minto Copper Deposit, with David Benson from Minto Metals. Go ahead, David.
Good morning, everybody. Can everybody see the front part of the title page of the presentation? Great, thanks.
Good, thanks.
Very good. Anyway, yes, pleasure to meet all your virtual acquaintance. My name is David Benson. I'm the new VP Exploration at the Minto Metals Corp now. I've been on the job for about 7 months, and this presentation is mostly just it's going to be doing a pretty high level summary of what acknowledging a lot of the previous work and interpretations that have gone on, and really looking forward to what we're going to be doing in 2022. Just some of the usual forward-looking and terms of use statements. So yeah, so here's the overview. We're going to be looking at basically an introduction to Minto Metals. Now, a lot of you probably know them from before as Minto Explorations, ATAC Resources, and it's been a journey that way. But we're now actually a publicly traded company. Again, high level look at sort of the geology, the ore bodies, the types of mineralization, the genesis deposit models. Then we're going to get really into some of our programming that we're coming up for 22 and beyond, and really the overall exploration strategy that we're trying to employ moving forward. So Minto Metals, we operate for those that don't know, we operate the Minto Mine. It's about 240 kilometers sort of northwest of Whitehorse. We have the largest actual land package in the area. The Minto Mine itself is on about 2,600 hectares of land. The Minto Mine is actually, it's entirely within the traditional lands of the Selkirk First Nation. Brief history. Basically, the mine was started basically in 2007, and to date we've actually produced just over 500 million pounds of copper. The current resources at the mine, we from a PEA done last year, is about 11 million tons at about 1.46 copper to the indicated level, and an additional 13 million tons at 1.29 inferred. We have a current mine plan in place right now, but only actually 60% of the total resources are actually in that plan. So there's significant opportunity in the looking ahead. We have a mill on site. We produce a premium concentrate, probably 35 to 40% copper, and we have a well-established long-term agreement with Minto Metals. Basically, just how we're mostly an underground operation right now. I'm actually exclusively underground operation. Right today, our plans and goals are basically 3,000 tons a day. Eventually, in the next few years, we hope to ramp up to 4,200 tons per day, as that's what our mill is licensed for. So we produce concentrate. We actually have we have to transport the concentrate on a via truck across a barge in the summer months, and across a winter ice road, which just came into play just earlier this week, across the Yukon River, and it's driven down to Skagway, Alaska, and then basically put on a freighter and off to Japan and other places in Southeast Asia. A lot of you guys have done a lot of the geological setting, and I'm sure many of you are very familiar with this, so I'll just quickly go through here. The Minto Pluton really it's part of a series of large plutons that intrude the Lewis group, right? And overall, though, it's good, this is representing the late Triassic to early Jurassic magmatism, and ultimately development of an island arc system, where and the end result being, with the arc continent collision, syn collision magmatism, and ultimately exhumation to where we are today. And so the Minto suite basically represents this syn collisional magmatism at the onset, basically, of accretion to the North American. The Minto copper belt itself, again, the Minto deposit here is located within the 204 to 195 million years old Minto Pluton. To the east is fault bounded with this the upper Triassic Lewis group Pavois formation. To the west, to the Yukon Tanana Paleozoic metasediments, and it's overlain by the Carmax group. Just basically a quick slide here on just the land position. Again, we have 26,000 hectares here in the copper belt. We share it, I guess, with the next presenters here, Granite Creek. The local geology, the ore deposits themselves are actually hosted within the Minto Pluton, and the Pluton itself is dominantly a megacrystic granodiorite, K-feldspar granodiorite with minor diorite pegmatite. Overall, there's a fairly ubiquitous potassic alteration throughout, and then it's manifested itself by secondary biotite and magnetite. There's also magmatic chloride epitite and epidote and hematite as well too. The ore bodies are actually sort of rafts and lenses within the actual Minto Pluton, and these are basically quartz biotite schists to gneisses, and in most places, especially in the high-grade ore, actual migmatite. It's all been structurally modified by late brittle faults. The displacements actually to date still remain unresolved, and the mineralization, it's the sort of the whole gamut from disseminated to foliaform, which are foliation parallel thin veinlets of mostly, well, and again, all the way net textured, and we do have massive sulfide as well too. The dominant assemblage is chalcopyrite and bornite. Here's just some pictures of the lithologies. I'm sure a lot of you have seen these in previous presentations and stuff. Here's the K-feldspar granodiorite. The amphibolite and the schist. I mean, this is the current interpretation of this is actually the remnants of basically a development of a porphyry system. The migmatite is the host to the ore bodies right now. Basically, this is a partially melted leucosome and melanosome of the actual porphyry from the Pavois formation. And we have abundant pegmatite and apatite dikes that you see cross-cutting, and again, just just notes on some of the alteration. Here's the picture of the Minto site itself here too. Just a longitudinal section here coming across here. This is the actual current ore bodies that are actually in the mine plan itself. As you see here, they're basically north plunging for the most part. We have a major fault right here, the depth fault, which basically cuts off these ore bodies. And for the most part, again, everything surrounding here, this is all basically the Minto Pluton itself. And these are sort of the schist migmatite packages within. What we don't really seeing in this image here is that these are just the economic ore bodies. There's actually dozens to even hundreds of other sort of migmatite hosted zones as well. Here's just some images of the mineralization. So here we have basically semi-massive bornite. Again, we see the sort of the whole range in styles of mineralization. There's definitely we see definite evidence of ductile deformation and flow. Other minerals as well too. We do see subordinate and multipyrite and chalcocite as well. Molybdenite, energite, electrum, gold, silver alloys, and there is some free gold, even though I haven't seen any of that today. On a deposit scale, there is a crude zonation. Right now, we're in the southern portions. We're basically looking at very chalcopyrite rich, and as we progress to the north, it becomes more bornite rich. It's unresolved, really, to date still, why that actually is occurring. So the genesis of the deposit model, I mean, it's from the literature that I've read, it's been sort of very hotly contested, right back from the days of discovery back in 1973. People have proposed that these are metamorphosed red bed copper deposits pre-existing. Some have just proposed this is actual magmatic copper deposits. Metamorphosed porphyry copper gold by Tafty in 2005 is pretty close as well too. Capstone Resources, who basically began the mine and mined it up until 2017 or so. They were going on the IOCG sort of genetic type model. Hood in 2012, who is we are working with as well too, Sean, moving forward here, proposed more of the shear hosted porphyry copper gold feeder or hydrothermal system. But really the sort of the latest and greatest is basically that the Minto ore bodies are basically highly metamorphosed to the anatectic partially melted copper gold porphyry. And this is basically the work done by Nicola Kovacs from down at the Carmax deposit and up at Minto as well too. So basically this thing, the genetic sequence of events, sort of there was the formation of in the late Triassic of copper gold porphyry deposits potentially, and this is in the Pavois formation of the Stakini-Lewis River arc. Then these were actually there's deformation, which ultimately deformation from essentially east-west development. This developed the schists and amphibole and the foliation or the foliiform foliation, or foliiform mineralization and the foliation parallel chalcopite mineralization. From there, then we actually have the intrusion of the early Jurassic granite mountain batholith, and they were basically the effect here was the heat provided to this actually caused partial melting of the Pavois formation porphyry, and it basically reorganized and ultimately upgraded or high graded the sulfides. It actually produced two sort of the melting produced two separate melts: a silicate melt and a sulfide melt. And then of course we have exhumation now in the late Cretaceous volcanism overlap. Where we're at, just basically with sort of the geological database, just looking ahead and what I've been working with to start here the program. We have over 1,500 drill holes on the property, and basically over 300,000 meters of drill. But we're actually relatively limited geochemistry, so we're going to be working at sort of upgrading that. We have a lot of historical geophysics, some large scale, small scale. Two of the real key surveys I just wanted to bring out here are in 2009, 2010 Titan 24 IP resistivity survey. All these surveys basically, or all the ore bodies that have been discovered beyond the original Minto main deposit were actually found with this survey. And also an excellent high resolution 2019 drone-based airborne survey. Moving forward, we're actually engaging with Goldspot Discoveries. They're going to be doing sort of a compilation and processing and interpretation of both the local and regional geophysical data. They're going to take a look at what geochemistry we do have, and providing some new interpretations there. We actually are going to be really developing the first real geological model for the Minto property itself. A lot of what we've been working with right now is basically dealing with the actual, just the ore zone modeling and stuff like that, but not really taking into account all the different factors. And we're doing this, and this is one of the things we're basically going to be applying the machine learning and predictive mapping, both in a supervised and unsupervised, to basically the entire geo database that we have. We're also working with equity exploration. John Bly and his team basically helping in reconstructing our entire database and then maintaining it moving forward. Like I said, some of the opportunities that we have, sort of the easy wins here right away, getting back to that 2009, 2010 Titan survey. I mean, I just put this image up here. This is basically the lines that we're running, sort of a north-south across, and for the most part, there was a fairly well tested. Basically in the core regions of the deposit here, or core regions of the property, but there's many untested anomalies that still have not even had a drill hole into them. And and essentially too, if you remember back to the earlier slide showing that longitudinal section, there's basically, we're pretty wide open, open to the north and at depth. The hopes here is that applying, with the unsupervised and supervised machine learning, this is really going to, highlight additional targets really at depth in the current mine block. So our proposed programming here, moving forward, looking at it, we have a current budget, board-approved budget of $9.2 million. We're going to be doing 30,000 meters of diamond drilling on the actual property, and this is following up on the untested targets on the Minto mine property itself, and then there is some already there are some old results that we can definitely follow up, and hopefully by the end of the year we'll be getting some results back from the machine learning, and we can start delineating. Another thing that was sort of not really done in the past here too, again with the characteristics of these ore bodies, these are generally higher grade. This is we're looking in grades in the 1 to 2 to we locally have up to 5% chalcopyrite. Again, not a whole lot of EM studies on the actual property itself either. So we're actually going to employ a borehole pulse EM accompanying along with all our new drilling. Another survey we have planned here too, and this is really just the follow-up to the 2009-2010 Titan survey. It's just basically using a passive magnetotellurics. The advancements that has been made, and I'm just highlighting in particular in the Spartan MT, the image resolution and basically down to about a kilometer depth is fantastic, and I think we're really hoping that we can really highlight basically the resistivity changes and ultimately targets at depth as well too. And we're going to apply this to the entirety of all our properties. We engage with exploration mapping out of Denver, Colorado, and we're going to basically employ the WorldView 3 spectral mapping for the entire for all the properties. And just you can look up WorldView 3 just to see what you get basically 17 spectral bands with some fantastic type data moving forward. We'll start tasking the satellite into position probably in June 20th of this year. Basically looking ahead just as an overall strategy just for the mine itself. I mean, it was a really aggressive program, you know, and basically in less than 5 years, we've been sort of challenged to really double the current resource base, you know, as well too, along with that, you know, we basically really, we need to replace, you know, replace what we're mining. So, you know, generally greater than 30 million pounds copper per year. As well too with this, you know, ultimately, you know, we're going to be needing to make significant new discoveries, and that's really the goal of the new geophysics and the new magnetotelluric survey. You know, it's really just seeing down at depths. You know, we're really looking at this from a perspective. It's we really need to see the, you know, the high grade portions, you know, potentially, you know, could be located essentially beneath our ore bodies right now. So, and one thing that we're working on, you know, in concert with our milling department is basically looking. We have an extensive sulfide oxide potential at site, similar to Granite Creek, and it hasn't really, as far as I know, really been looked at in detail to date. So we're looking at that potential for us. And as I said, just for our regional properties, really going back to sort of first principles. There's been a lot of good work, sort of localized work done, but we're gonna go back, and that's the reason for the Worldview 3. So this year is we're going to be doing that, and get some interpretations, start the permitting process there. Next year, hopefully we can be doing some anomaly follow-up and prospecting, potentially some airborne geophysics. By 2024, though, we really want to get, you know, really hopefully can be focused in on some new targets, and we, you know, really begin the drill testing progress. And that's about it. Thank you very much. Thank
you, Dave. We'll continue in the same general region, move a little bit further south and look at what the neighbors have been up to at the Granite Creek Copper. Jacob Longridge will be presenting for Granite Creek. Oh, and by the way, I should mention Jacob doesn't have a camera, so you won't get the chance to see what it looks like.
Probably for the best. So yeah, thank you everyone. Thank you for inviting us to this talk. And Dave, we should probably have a chat because we're working in the same district, and I think there's a lot of similarities between our projects. I'm a geologist that's working for Granite Creek Copper. Today I'll be talking to you a little bit about a kind of holistic review of the deposit, what we understand to date, as well as going over what we've done since acquiring the asset in 2019. So I will be potentially releasing some forward-looking statements. So just make sure you read that. So yeah, Granite Creek is a fairly young company. We're in our 3rd year anniversary. Today, what we've done is we've consolidated 177 square kilometers of the Minto district, acquired the Carmax deposit, which had PEA on it, done in 2017. We launched a 1,000-meter drill campaign. I'll be talking about some of those results later on in the talk. And we kind of compiled some of the historical drill hole data, some of the geochemistry, regional geophysics, as well as some of the local geophysics. And what we did last year, we did a 10-kilometer, 3-phase drill program, both diamond drilling and RC drilling. We did 20 kilometers of IP over Carmax North, which was formerly known as the Stew property. We engaged Goldspot AI to review some of the data that we've compiled and assist with some geological targeting. And we were kind of in a really good position to review the mine plan, kind of take a little step back because previous property owners were focused primarily on the oxide portion of the deposit. And so we had the opportunity to kind of look at things from a holistic perspective, and we kind of test those ideas out with the drill. And for anyone in the US, we did our list to OTCQB, if you want to look us up there. And so some of the things to look out for in the next little while, we'll be releasing the third phase of our drill results. We've engaged SGS. They will be giving us an updated resource when we get the drill results. So we're kind of itching to get those results in. We'll be releasing some of the gold spot targets that were developed. And we could potentially set up a update to the PEA, and we'll be announcing our plans for this year in global pandemic, which is always a fun logistical challenge. So yeah, we're 22 kilometers south of Minto. We're, really looking forward to seeing how things at Casino develop. We're on the Free Gold Road, so we've got road access right to the property. We're within 12 kilometers of power, so that's really looking good. We're in the right area. We've got good access, and so I'll just kind of run through the regional geology as David has kind of already done, but I'll just kind of recap some of our understandings and encapsulate what Nicolette has basically advanced in the recent years. So yeah, basically just kind of overview of the terrains. We're within the Stikinia terrain. Kind of looking at the basement rocks, so the pre-Triassic rocks. You can see the key part here is the Finlayson and Moose Formation. Just those ages are quite interesting for us because of the dating work that we'll get into. Potentially ties into these being inherited within those rafts. Then looking at the work that was done by Patrick Sack and everyone else who was part of that atlas for Triassic and Jurassic Plutonism. It's really a good read. I'm just summarizing some of that information here. The most important part is the emplacement of the Minto suite. Basically, there's a bunch of plutons that are in place. They're all part of the Minto suite. What's quite interesting later on is both Minto and ourselves are basically fault bounded on all sides, so we can't really see the relationship between the batholith and the host, which we interpret to be potentially some of that Devonian Mississippian age rocks, as you can see in the Tachuan batholith there. And then we get into, so then looking at the amphibole geothermobarometry that was done by Patrick Sack, I've kind of plotted up the general depth estimates for these batholiths. And what is quite noticeable is that the Granite Mountain batholith is in place at a higher level than the Minto batholith, even though they're part of the Minto suite. And I mean, this is quite interesting, especially considering what Warwick was mentioning earlier in the presentation. Thank you, Warwick, for highlighting potential prospectivity of our batholith. Although some of the things about timing need to be probably thought about and discussed. And kind of looking at the post-batholith emplacement, there's the long suite, intrusives and the Gregor batholith, and then getting into the Cretaceous volcanism and porphyry rocks that were deposited at that time. What is most important to our property is the Carmax volcanics. The Carmax volcanics kind kind of cover some of the area. They are basalt, so they provide a bit of a challenge when using aeromagnetic data because they can obscure things. And then you had the faults, and then finally Cenozoic volcanism and movements along the Tintina fault. So that's just kind of a quick review of the regional geology. This is again from Patrick Sack, just a kind of schematic section through the crust as it sits now and our current understanding. The Carmax deposit sits in the Granite Mountain batholith within the Stikenia. Looking at the local geology, yeah, we're within the Granite Mountain batholith. A lot of the mineralization is within these rafts, very similar to Minto, that are entirely within the batholith. These are pretty much all the zones that we're looking at and we're reviewing. Most of the work that we've done to date is on the Carmax deposit, although we've provided access through to Carmax North and started doing some IP work there that I'll be talking about in a little bit. So when we kind of got to the property, one of the first things we did is we tried to familiarize ourselves with the geology. So we got into the Discovery Trench and had a look at the rocks there. And I think there's some key paragenetic events that can be seen at this outcrop. So basically, you're looking here at a raft that's encapsulated within the batholith. Looking within the raft, you see there's fairly intense deformation, and that seems to be cross-cut by these quartz diorites, and finally with these pegmatites. So I think that's a key relationship there, is the batholith cross-cutting that foliation fabric and cross-cutting the migmatization. Looking at the fantastic work that was done by Nicolette as part of her master's thesis and ongoing publications that have kind of come out of that. We're looking here at the dates from the raft. This was chemical ablation TIMS, so they were really able to constrain some of the dates, provide narrow error bars, which is great. And yeah, we've got this precursor event around 217 million years. Then another event within the raft that's around 205 million years, and then migmatization, and finally batholith emplacement. And I'm sticking on the rhenium osmium dating of 4 moly molybdenite crystals that she dated. All of that mineralization occurs pre-batholith emplacement. So that's a pretty important thing to consider when you're looking for more of these rocks. We kind of took a step back and looked at what was done at Minto. Sean Hood did a master's thesis in 2012, and he identified these copper sulfides within garnets. At the time, because there was no deformation present within the garnets, he tentatively suggested that they may be co-magmatic. We, looking at the observations that we've seen in at our deposit, we think that those copper sulfides probably occur during metamorphism and prior to batholith emplacement. So kind of new look at the same sort of data. And because we come from a porphyry background, I've got my PhD in porphyry deposits. One of the key things I do when we're logging core is look at cross-cutting sequences to establish some sort of timing. And what kind of is quite encouraging is the local observations really sit quite well with our regional understanding and with the dates that we have to date. So all the mineralization, or most of the mineralization, sits prior to the batholith emplacement, and alteration, so hematite, chlorite, clay, carbonate, alteration is very recent. We don't view this as being this alteration as being part of the mineralizing event. We think it potentially could be coeval with the Cretaceous volcanics, such as the Carmax, some of the faults that are coming through the deposit, or potentially the thermal collapse of the batholith. So that was just a very quick overview of the sequence of events from the late Triassic to the early Jurassic and Granite Mountain batholith emplacement. I'm not going to go over this because I feel like I've made the point fairly clearly. What is quite peculiar, and I still am trying to wrap my head around, is what was the mechanism of mineralization and the geodynamic setting that accounts for amphibolite facies metamorphism of Triassic age. So these rafts going up, being migmatized, and then entrained by the early Jurassic. It just seems like a lot to have happened fairly quickly in a short period of time. And just kind of a point of discussion is this potentially part of a subducted slab that's then been entrained by the batholith as it's kind of coming up? I'm just kind of putting it out there. Feel free to have a chat with me about it. So yeah, kind of going into what we've done to date and getting out of the conceptual world and into proving ideas with the drill. I'll be mostly talking about what we did at Zone 1, 2000 South, and Zone 13, where we have resources, and we try to achieve different targets at those different areas. And I'll be just touching on some of the exploratory work that we've done. Unfortunately, we don't have enough time to kind of go into all of it, but I will be at Roundup, so we'll be happy to chat about some of that stuff if you guys are there. And then kind of concurrent to all of the field work, we've also engaged Sedgman and Mining Plus to kind of review the mining plan, potential for underground versus open pit scenarios. We got BV to do some metallurgical testing of the sulfide to see how well it responds to typical flotation setup. And then we had Steinhardt review ore sorting technologies such as XRT scanner to upgrade rocks. And then, yeah, basically we are currently in review with SGS on updating the resource, bringing in some of the drilling that we've done to date. So without further ado, this is Zone 1. This is the access road that connects us through to the Free Gold Road. And we'll be zooming in to Zone 1. The Discovery Trench is just down here. This is the 2016 PEA. What we did notice there was that the about 20% of the tonnage there is at a significantly lower grade than the rest of the deposit. And so what we wanted to do was we wanted to increase the confidence of the inferred and potentially extend the mineralization down to the south. What is of note is the overall grades of the intersections. A lot of the sulfide portion of the deposit was defined by down plunge drilling that we'll get to in a second. We'll spin around. And so, yeah, basically what we did is we drilled it correctly just to see what the grades would kind of look like there. The grades in the sulfide look to be higher when we drilled it correctly, and when they did that downhole drill, it might have drifted into the hanging wall portion of that raft. So looking at Zone 2000 South, we had a similar idea there. We kind of knew that the raft existed. we just wanted to continue the extension of that down dip outside of the inferred category. 30% of the inferred was fairly high grade. So yeah, we wanted to expand that. Let me just bring that back a little bit. Expand that, upgrade the inferred classification tons, and then also define the southern fault of that zone. So that was more of a geotechnical hole, which was very encouraging. So we're spinning around to hole CRM 21-2011. And what is important about that is we drilled 40 to 130 meters below the base of the inferred resource there. And if you just look at the grades of that compared to the grades of the resource, it's looking fairly encouraging there. And then going down to zone 13. Zone 13 was a bit of a conundrum to us. It's a fairly large deposit. Oh, sorry. Compared to 2000 South. But what is intriguing about it, yeah, is it's larger, but it's lower grade. We also, well, yeah. So our objectives of this zone was to fill in this void that was plaguing the model, just see if that was a valid void, and continue seeing what the thickness of the northern portion of the zone is, confirm those sulfide grades. So this is the 2020 drilling that we did. What we intersected there was 127 meters of 0.85 copper equivalent, so it's straight through the guts of the zone, which was very encouraging for us. When we did a step back, we intersected this eastern fault, which defines the eastern limit of that zone. And then kind of looking at hole 16, we had a much thicker intercept than we anticipated. So it looks like the volume of material there might increase. Just kind of looking there again at some of the highlight holes that we drilled and comparing those to the grades. We're quite excited to see how the resource updates. Jumping into the metallurgy quickly. I know I'm past my 20 minutes now, so I'll wrap things up. In 2015, there was acid leach for copper and the cyanide leach for gold, a vat leach process to extract the oxide. The recoveries there were very good. So we're pretty happy with those results. We initiated a test of the sulfide potential and see how that behaved in a flotation cell. And because chalcopyrite accounts for 90% of the copper, and the gold was refractory, it delivered fairly good results for us across a fairly wide range of head grades. So we're pretty happy with those metallurgical results. And quickly jumping to the north, Carmax North, we did about 20 kilometers of IP over Zone A, part of historic stew showing. What we saw was a number of zones of high chargeability, and as David mentioned previously, these rafts respond fairly well to IP, so we are fairly encouraged by these results. Unfortunately, we didn't get to drill them. Kind of zooming into kind of this little zone here. This was where the majority of the drilling was done in the 80s and 2020. In 2020, there was a hole that was 4%, 4.31% copper over a 4.6 meter interval. But that just looks like it's the tip of something potentially larger. So we're quite excited to kind of get back there and build up that story. And just quickly going over some of the sediment work, we looked at optimizing the plan, potentially bringing the sulfide into a mine plan, bring the other zones, not just one, but 2000 South and 12 and 13 into a mine plan. We had them review different leaching methods and various underground mining methods, especially on zone 1. And this will potentially lead to an updated PEA once we've got a resource updated. You know, it's down to the hard work of our team that we are able to achieve so much in such a short period of time. Here are the names of most of the people who helped the project advance, as well as some of the key contractors that were involved. So thank you very much. I'll leave it there.
Thank you, Jacob. Good to hear what's happening at Carmax Copper, and I'll come back in the chat. We'll just move on straight to the last talk of the session, but I think I have an answer to your question, so we'll come back to that in a few minutes. So now we're going to end the session with late Cretaceous porphyry target, and this is the Hopper project near ATAC Lake. And Luke Bickerton with Cavu Mining will present on this for us. Thank you.
Okay, I think my mic's on. Yeah. So thanks for having me. This is an update on the exploration at Hopper, but also a bit of an introduction or reintroduction, since it's a new project for a new company here and the property that hasn't been explored in the last few years. So I'll take you through a bit of the history and then what we did this past year. So again, the forward-looking statements to go through, and just a brief intro to Cavu Mining. We were just formed last year. We have been invested in 2 different assets right now, one being the Hopper and one just outside Kitimat in BC, and both are near surface copper and gold mineralization with existing infrastructure nearby. So we have a great team of capital market pros in Vancouver, and then the technical side, including myself, have been in and out of Yukon in the past 10 years, including a lot of work on porphyry copper deposits. They're listed on the Canadians Exchange at CAVU. The Hopper property is a couple hours drive away from Whitehorse. It's road accessible along the ATAC Road, about 50 kilometers north of the turnoff. It's again just on the western side of the property, pretty close to a government maintained dirt road. The regional geology was pretty well covered in the morning talk, so I don't need to really elaborate further, but just to show you the context, it's in the middle of a northwest southeast trending belt of Yukon, Canada, metasedimentary rocks. To the east, you have the Long Lake early Jurassic intrusive suite, and to the west, more Paleocene Ruby Range. What's interesting about this part of Yukon is, including in the Long Lake batholith, you have the small intrusions of late Cretaceous age, and as has been highlighted over and over, that late Cretaceous age is pretty important for metallogeny in Yukon. Hopper itself is around 78 MA, similar to the Lansandland and Moraine and Sato. And of course, you get a little bit younger as you move your way north into Plaza, Revenue, Nucleus, and Casino. The other important feature that I think everyone takes note of is these northwest southeast trending structures, and these are exist along that Casino through to Free Gold area, but also in the southwest part of the territory. They're a bit more masked, but this prevalent structure exists. little more zoomed in on the property, the hopper outlined in red surrounds the hopper intrusion, which is medium to coarse grained, hornblende quartz diorite into monzonitic compositions. There's also a series of north-south trending dikes, quartz feldspar porphyritic dikes, which have been dated to be late Cretaceous. And then there's also some more felsic dikes, which are more Paleocene in age of a similar trend. The host rocks to this is predominantly the Finlayson assemblage in the Yukon terrain, which is in the area of the property, some thick marble with interlayered schist. And so one thing to note as well, although these folds and cross section are shown to be regionally tight, and you see the different limbs on the property, we just see this strata as gently dipping to the north and east. So pretty predictable horizons of marble. So a bit of a history here. The first recording in the area was on the Helen Claim in the Franklin Creek. You see on the right side of the map here in 1905. And the next real geological work done on the property was in 1968, where Mitsubishi Metal Mining Company did some mapping. And you can see they noted some porphyry dikes and as well as andesite dikes, and the contact with the hopper intrusion and Yukon metasedimentary rocks. And then the first drilling was done by Whitehorse Copper Mines in the late 70s, and they intersected skarn outside the Franklin Creek, which pretty rich horizon, almost 20 meters of around 2% copper. And then fast forward to 2006, Strategic Metals picked up the property, and Archer Cathro and them have been exploring ever since to the breadth of data that we have now, which includes over 2,000 meters of diamond drilling, over 20 holes, and over 2,000 meters of percussion drilling, over 46 holes that spread out across the property. So in 2021, just January of last year, the Cavu Mining entered into an option to earn 70% interest in the hopper property. Again, this model has been shown quite a bit this morning, and it goes with the porphyry theme here. The analogous processes that we associate with the hopper is this porphyry's mid-level exposed porphyry setting. One of the more obvious connections is the high-grade copper gold skarns that can form proximal to these metal-bearing intrusions, and that's been well defined at the hopper by drilling, but also at surface. Skarn actually daylights, and you can see pretty green rocks at surface, and this is backed up by drilling, where we actually see horizons of massive to semi-massive chalcopyrite and pyrrhotite, which are repeating with depth, and you have at least 6 or 7 horizons that show pretty good grades averaging. Whereas in the north part of the property within the hopper intrusion is where we followed up with some porphyry style mineralization encountered in 2015 drilling. With our own drill hole, and we encountered more typical porphyry vein hosted to disseminate style mineralization and alteration, which I'll show you a bit more of in the next slide, focusing on that northern part of the property and the newly or underdeveloped porphyry part of the deposit. So these host rocks are, again, monzonitic in composition from medium grain to coarse grained, and multi-phase. This intrusion has a variation of grain size as well as somewhat variation in composition, without much of a chill between intrusive contacts. So I think that the complex is pretty similar in age, depending on what phase you're looking at. And they're all cross-cut by mineralized veins where you see them. There's also a thin porphyry dikes that cross-cut the property. These are ports to Plagiauric. And then looking at alteration, we do have predominantly a chloride epidote overprint in the area. You can see this is, in this case, associated with a quartz moly vein. Locally, you have repeating veins with K-spar altered envelopes. And then also somewhat locally with the drilling that we have, you have quartz-sericite pyrite alteration and more phyllic style spots. I show mineralization here with a couple of veins with chalcopyrite associated and some bleached halos. And there's also chalcopyrite in these K-spar halo veins. And then it can also occur as more splashy replacement to disseminated style. And the bulk of the mineralization that we did see in the porphyry hole that we drilled is disseminated style mineralization. And it's not really worth showing a picture of the core, but it essentially looks like the host rock until you put a hand lens to the mafic sites and you see that there's little bits of chalcopyrite replacing a lot of the mafic sites. So it's pretty intriguing because it results in pretty long intervals of low-grade mineralization. So in 2021, we kind of quickly turned around from acquisition to drilling, and in just 4 months, we were able to secure financing for a small drill program, just under 1,200 meters. And the main goal of that program was to evaluate, for one, the scope and size of the skarn mineralization and the average grades as a way of moving that closer to a resource. And then also testing the data set that we have for porphyry style mineralization in the northern part of the property to see if we can effectively target further mineralization there. So I'll take you through firstly the skarn mineralization and the drilling that we did in this copper, we're calling it the Copper Castle zone, which is above, north and just south of the Franklin Creek of the initial discovery on the property. So on the right, you can see the property scale EM VTEM survey that was flown in 2007 and reprocessed in 2011 and 2013. And you can see there's some EM highs that are anomalies that were pinpointed for exploration. And we zoom in on the Copper Castle zone. On the left, you see the Franklin Creek in blue. I'm not sure if my cursor shows, but the Franklin Creek bisects one of these EM highs, and a bulk of the drilling was actually done north of the creek. And we wanted to test this EM high south of the Franklin Creek to see if the skarns are extendable south of that structure. And it resulted in intersection of some pretty high-grade skarn horizons near surface. And so there is potential for using this as a tracker for at least one of the near-surface skarn horizons. We also did a great deal of interpretation on geophysics and flew new higher resolution airborne geophysics across both zones. On the right, you see the flight lines flown by Precision Geosurveys in 2021. And we're able to, one, use MAG to identify some predominant structures through the property, but also the hopper intrusion itself, which has quite a bit of disseminated magnetite. So these MAG anomalies were chosen as a way of tracing, one, the intrusion, but also anomalies within the intrusion of MAG content. And when we line that up with soil anomalies, as well as IP survey done by in 2014, we were able to use this as a target for the drill hole 06 you see in the porphyry zone. So I should go over the soil geochemistry just to show the distribution of soils that's been done in the past. You can see it's quite extensive. I just show copper and zinc here to give you an idea of what these soils look like depending on what zone you're looking at. So in the Franklin Creek, I noted, or in the Copper Castle zone north of Franklin Creek, I noted that these skarns actually reach surface, and that's why you see such elevated copper values. And this correlates also with moly and gold, and it's pretty easy to use soils there as where you would find skarn mineralization. What's interesting with that zone is south of the Franklin Creek, where 3 of the drill holes were done. There's very little anomalous soils, and this is due to more overburden. So we just use the EM to trace the skarns there, and there's potential to extend this zone despite the lack of soil anomalies. In the northern part of the property on the ridge top is where the porphyry zone is, and you can see it's kind of a weakly elevated values, especially relative to where the bluff is and the skarns are exposed. But there is elevated copper, and this correlates also with gold, and moly. And so that lined up with the mag led us to a good use of targeting for this porphyry hole, and we think we can extend that further east. Just to show the zinc, it's kind of interesting to see that, again, distal to where you would think the main deposit is, you have elevated zinc values. Whether or not this correlates to lithology or the bedrock is something else. So again, this is the Copper Castle drilling. We drilled 5 holes to try and define the skarn horizons, how many there were, how deep it goes, and if we can extend the known skarn horizons south of the Franklin Creek. The first 3 holes were quite successful in doing this. You can see some of the intercepts, including over 20 meters of 1.4% copper and elevated gold and silver. And again, a look at, it's just semi-massive sulfides and then pretty easy to say that these skarn horizons do extend south of the Franklin Creek. Hole 4 and 5 were used as a way of sort of characterizing the skarns the closer you get to the hopper intrusion. And they encountered not as high grades, but they encountered at least 6 or 7 skarn horizons with this shallowly dipping strata. As for the hopper north or the porphyry zone, hole 6 followed up a drill hole done in 2015, which encountered the granodiorite to diorite midway down the hole and some fault associated copper mineralization, but pretty consistently low grades. So we followed up using the mag and the soil anomalies to get a nice hit near surface over 100 meters of copper mineralization at greater than 0.2. And then we encountered some mafic dikes further downhole, and so that's why the grades are pretty diluted once you get further downhole, but it's a great start to further define this porphyry target. And so it included in the rocks, picking out these K-spar altered vein halos, some variable vein density as you go downhole, and of course chloride alteration throughout, which is typically secondary in overprinting biotite. Yeah, so one of the things to note, I guess, is the hole 6 started just on the margin of the mag high with the soil anomaly above. So going forward, we're going to have to try and figure out the correlation between these 2 targeting tools. Overall, the property has pretty well proven metal endowment. The skarn especially is well defined by drilling over a kilometer by half a kilometer open for expansion, and the Copper Castle footprint, we were able to extend that south of the Franklin Creek with the new drilling. And using the EM, there is potential for a further 1.5 km strike of these skarn horizons, depending how rich they are. So there's potential for volume there, both southwest, east, and at depth. As for the porphyry style mineralization, we do see a similar style to the textbook porphyry characteristics. And we need more drill holes to really understand, but based on alteration, we think we encountered a low-grade altered margin of mineralized porphyry. So we can use the good data set that we have to target these two separate deposit styles going forward. And thank you. So I should say that we're fully financed for a drill program this summer, and we look forward to presenting the results next year.
Thank you, Luke. Good presentation. If you can release the screen, and then if I could ask all of the presenter for the morning to come back on screen to turn their video back on and be ready for a little Q&A session. There are a couple questions, but if anybody still in the audience has more questions, please fire them off to us. This is the time. There were a couple that came on into the Q&A while we were going to the talk. Some of them were answered directly. I'm not sure if everybody has had a chance to see that, but maybe we can walk over those again, just to make sure that that's been covered. But maybe we'll start with a question from Jean Potler to Steve Israel. Jean was asking, would the Oligocene Miocene porphyries like the Min be part of the Northern Cascade magmatic arc? Up to you, Steve.
Yeah, good question, Gene. I would say sort of, and saying that the margin of North America at that time by the Oligocene is more or less a transform, basically from Vancouver Island up to northern BC. And the subduction carried on, as I had mentioned, down in the North Cascades, but it also continued on up under Alaska, and essentially became the initiation or the precursor to the Aleutian Arc. And I think that that is essentially what the Wrangell and probably the Tecumseh Suite are related to, subduction related to that, the generation or the precursor to the Aleutians rather than maybe the North Cascade, but within the same sort of tectonic framework. Hope that answers your question.
Okay, well. Did you get this, Patrick?
No, you disappeared there for a second.
Okay, yeah, my internet has been flickering for the last hour or so, but so Patrick, would you want to walk back over that question that Kelson had to you that you answered in the chat?
Yeah, sure. So Kelson's question was, with the date on the flex zone of 108 MA, which is different than that at Prospector and Casino in the Cypress Kelly areas, what age do I think the flex zone is attributed to? And so as I sort of typed to Kelson in the chat there, I think that rhenium osmium date from the flex is the first kind of well-constrained mineralization age out of those Brown McDade deposits, and sits at, like you said, 108. So that ultimately makes it genetically related to the Whitehorse Suite Plutonism and the mid-Cretaceous stuff. So the most, the finger points pretty straight at the Dixon Knob, which is a porphyritic plug that's I don't know, a kilometer or two in square kilometers. And so about the right size, and it has a spatial association with most of that mineralization as well. So to me, that would be the source or the genetically related to those veins in the Brown McDade cluster, if you will.
Yeah, my internet is quite unstable, so I'll see how long I can stay on this. But the other question we had in the chat was for Carl, and this was mostly about your scanning of core. Carl, you want to walk back over that one?
Sure. The question was how much manpower was involved to scan the core. Of course, I haven't added up the hours, but it's we at Aurora, we employed 3 people, 2 in a day shift, 1 at night, to consistently find the core, get it set up. Then we moved it into a tent, sort of just to cover it up, and then we cleaned it, made sure it was washed and free of debris and whatever's collected over 30 years. And then we moved it into a core shack and had it ready to go. And at that point, we just kept feeding it. So we kept the cycle going. And at the end, of course, it all had to go back. So it was, it took a little bit to get it to be really smooth, but it took 3 people basically a summer to do. I would estimate, if you include the 2021 and some of the 2020 core, a little under 60,000 meters the entire summer. Plus there were 2 technicians that worked at the on the actual Microsoft. So even though it goes fast, if you got enormous amounts of core, it's still, you know, you still need a fair bit of manpower to run it. Thanks.
Carl, just looking, I guess, Jake, I kind of mentioned at the end of your talk here, well, thanks for everybody who kind of mentioned the work that Patrick was first author on, that I collaborated with him on, that our Atlas of Jurassic Plutons, which is open file 2020-1. So if you don't have it, grab a copy. But I will also advertise that there is a paper. So that open file was basically mostly a raw data dump with some very low level interpretation. I do have a paper that's in the last stage of review with tectonics, which addresses the magmatic and tectonic evolution of that time. So hopefully, once that paper is available for you to read, Jake, hopefully that will answer your question about what's mysterious about that late Triassic, early Jurassic time. To give you the short answer is basically we're going, this is the end of the arc system in Yukon, and we're going into a synccollisional belt. None of these early Jurassic plutons are actually arc plutons, which, you know, we long called them that, but our study of those plutons is really kind of showing that they're not related to the arc magnetism. The arc magnetism is in BC at that time, and we don't have it in Yukon. So anyway, just a comment on that. Any other questions from the audience or panelists?
Can I ask Carl a question?
Sure.
Just a quick point there, Carl, about just to bring your attention to the fact that there is just to the north of Casino a significantly anomalous aeromag interval that coincides very well with one of your new targets. I just noticed while you were speaking. So that's something you might want to keep in your back pocket. The question I wanted to ask you was, when you scan the core and you with LiDAR, what do you actually get? What does the LiDAR tell you when it's scanning the core? What sort of information do you get from it, from the LiDAR specifically?
I'm not really sure exactly how to answer that. It's I think what you're going to get is small amounts of depressions in the core. You know, if there's any kind of structural aspects, any kind of differential weathering, that sort of thing. Okay. So this is actually the first time I've actually worked with something like that. So,
okay.
But
it's really interesting stuff, I must say.
It certainly is. I mean, all the things that it can do is really impressive.
Okay. All right. Okay. Thanks.
No, thank you.
I have a question for you, Warwick.
Ask away.
Is in all your figures there, is predictive the same thing as saying prospective?
Yes and no. Being a geologist, I can say yes and no in the same sentence. It's predictive applies specifically to the difference in the weights. I know this is a mathematical term, but it gives you a sense of just how predictive the rocks are for mineralization. Whereas prospective, or probability-wise, gives you a quantitative number as to exactly how much more prospective one rock type is relative to another. So these are two metrics, Patrick, that you can use, but they have slightly different purposes and they tell you slightly different things. So in this vein, then the next step, I think, with this mapping that I'm sort of trying to finesse here is to apply further means to take these quantitative indicators and add more value, like, for example, applying some machine learning algorithms to see what we can do with it and stuff like that. It's a really big, it's a big topic, and 20 minutes is not enough to work through it. It's because there's a lot of kind of subtleties involved in the whole process. But anyway, I'm sort of segueing into something else. So the answer is they are both important in terms of prospectivity, but they give you different information that you can use differently.
Yeah, I guess I questioned or I wondered because a lot of the early Jurassic, late Triassic plutons popped up as strongly predictive, and in the Porphyry realm, I would argue geologically that that's about as far from the truth as you can kind of get. The exception, obviously, being these raft things and the Minto Carmax copper, but in terms of proper porphyries, that's quite a conundrum, I would think. Anyway, we don't have to solve it. I just wanted to ask it.
Yeah, I just wonder if it's telling you that the batholiths potentially could form porphyries. So it's showing the right signature, but the tops of them have just been cut off. So the actual porphyries themselves are no longer exposed. I just wonder if that's what's kind of coming. I'm looking forward to kind of going through that map and seeing how those products were derived. Because we should be looking around for more typical porphyries. Which is not really what we're doing. We're looking at those rafts at the moment.
And I think a key take home is that the whole exercise is purely data driven. So whatever the outcomes are based on the back of solid data, the data being mineral occurrences and deposits. So it'll tie in for sure.
And there's so we need to, even from, you presented a bit the summary of the barometry, Jake. And so we're missing 20 kilometers. Like your porphyry is long gone. So if you want to find the Jurassic porphyry, the place to look for it is in the sediments in the Whitehorse Trough. Steve, I have a question for you. I think we've talked about this over the years, and I'll ask it. Don't know, we'll see what you have to say about it now after looking at some of the stuff. But when you were talking about the Whitehorse Suite, and then you showed that reconstructions, I think you were trying to point that there might be some connection between the Kluane early Cretaceous and the Whitehorse early Cretaceous. Is that?
Yeah, that's right.
What do you do with that East-West Maloney batholith?
Maybe that's a question for Craig. I don't know. I don't know. Maybe it's following a structure. I don't know. It's because it falls a little bit outside of the main sort of magmatic axis or axes. So yeah, I don't know what to do with that. It's a little bit out of place. Sorry, Bob.
No, that's fine. I'm just wondering if you had any further thought on that. That's kind of a weird, I don't know. We don't have a map here to show if maybe people don't follow what we're showing, but when you look at the Yukon map, you'll notice that there's that, early Cretaceous batholith that's completely out of trend, that just runs almost east-west from the south end of the Dawson Range, which is kind of a weird.
Yeah, I mean, if you really look at it, you keep going to the east, and you've got that trend of ultramafic rocks that are sort of following it, or at least following the same trend of the batholith. I mean, that might be indicative of a big fault that runs through there, and may provide the conduit. But yeah, I don't know.
Yeah. Okay, the other comment I had in my notes here was Adam, for your Connaught project, where you were, this is more of a regional geology's comment, but the boundary, like at the south end, you pointed out there's a faulted boundary with the 60-mile batholith, that Grass Lakes Ogden Granite. And I think that generally is thought to represent the continuation of low angle extension faults that are well documented in Alaska. The work hasn't really been done other than speculating about this in Yukon. But if you look at the Argonne data, you'll see that everything south of that boundary is generally Cretaceous. cooling ages in the micas in argon data, whereas if you go north, you're usually dealing with more of a Jurassic cooling domain. So just a comment passing from.
Thanks, Mo. I'll check that out.
Any other questions? I don't see anything popping up in the chat here. I think if we don't have any further question, I think we can probably call it a session. Brianne?
Thank you very much, Maurice. And thank you to all of our speakers, Warwick Bullen, Patrick Sachs, Steve Israel, Carl Schultz, Adam Colchard, David Benson, Jacob Longridge, Luke Bickerington. And again, please sign on to our online auction. There's some really great items on there donated by some even better Yukon companies. And join us for next Tuesday's session, January 25th, session 5, for our Yukon Gold exploration talks. We have talks from Banyan Gold, Snowline Gold Corp, Whitehorse Gold Corp, Yukon Geological Survey, Stratabound Minerals Corp, and resident Yukon geologist Ryan Burke. Again, thank you to our partners, Yukon Government and BMC Minerals, and to all of our sponsors. I'll just mention a couple of them here: Rockhaven Resources Ltd, SLR, North Country Consulting LP, Minto, Evor, Kluani Drilling, Banyan Gold, Casino, Horizon Helicopters, and so many more. Thanks again, and we look forward to seeing you next week.